Hi, I thought I'd talk about a few things before I get started with this video. I just wanted to mention a few useful things that you might want to know. So a lot of the code and the things we do in this video or this screen recording is that I talk about extruding a 2D mesh along a spline. I gave a talk about this quite a long time ago in 2015 at Unite, and the slides for that are available. So I'm going to link that in the description below the video. And many people also ask me if there's source code to this, and I'm going to include that too. So if you are supporting me on Patreon, you also have access to the source code. And this source code is also heavily annotated. I've also cleaned it up a ton, so the code should be much, much more readable than what we actually did on stream. And I also added a few extra features. So in the talk, I also mentioned like a better way to do UV coordinates for the road. I cleaned that up and I added that feature to the code. So now I added like this delta compensated UV coordinates, which makes it so that the texture kind of compensates for there's like stretching in Bezier curves, and that will compensate for that stretching. So textures mapped to your object will look much, much better. So that's added in the source code, and that's available for everybody who's supporting me on Patreon. And I thought I'd also say thank you so much to all of you who support me on Patreon. You really do allow me to do all of this stuff, and it's so much fun, and I really enjoy this. So I just wanted to say thank you. So if you want that source code, if you're already a Patreon supporter, you can just go there. Also, I wanted to ask two questions because it's useful for me to know like what you want to get out of this and whatnot. So first off, do you think I should make a few more like pre-recorded things, like pre-recorded tutorials that I can like edit together more tightly, rather than just uploading stream recordings? Because like stream recordings can become kind of meandering after a while, where I get off on tangents and I'm a bit slow. So I just wonder, like, would you like to see some pre-recorded tutorials? Just let me know. And also remember that would like kind of come at the cost of more streaming. So there's always a trade-off in time, right? That's just the unfortunate reality of how time works. Yes, the other question, in these videos, I have like short clips in the beginning showing you sort of the different parts of the code that I've also linked in the description as timestamps. Is this useful or is it not? I think the most of the time I spend editing these videos is making those sections in the beginning. So if that's not useful, then might as well just not do that, and that way I can upload videos faster. But anyway, if they are useful, I'll just keep doing it. Right, I think that's it. Sorry for the long preamble, but yeah, I hope you enjoyed the video, and I do hope that you find this super useful in your projects. Thanks. I I might lose focus or drift a little bit during the stream, because I got incredibly high last night to an extent that I didn't expect. Triangles are usually what has the connectivity information for how these are connected. So here's one triangle, and then we can make it. The way you define triangles can be a bit strange, because it's a very odd way to assign things, but it'll make sense. We want to have an inner radius, right? So that's going to be the distance here. So that's going to be, I can enable the tangents for this curve, and I can reshape this one however I want, right? So now if we move these points around, you can see that this curve is changing its shape, right? And that's good. So now we're starting. If we then draw a point on that one that is using the same t value at the bottom here, that is the point that is traversing across the entire Bezier curve. So now we have this shape, and you can see that this is exactly the shape that we want to have for the final mesh, and we can move this one around like this, right? What a weird road this is, but it works. Yeah, so now we can deform this whole thing. We get some interesting things happen. Okay, just a heads up for those of you who are early. I might lose focus or drift a little bit during the stream, because I got incredibly high last night to an extent that I didn't expect. I think some of that is still lingering, so feel free to let me know in case I'm like getting stuck on something. Anyway, otherwise I'm guessing we should get started pretty soon. I don't think we're gonna hit the 10 o'clock mark, but yeah. Hey Foxite, Thank you so much for the resub. That is super nice of you. Lingering high stream. Yeah, that's that's what we're doing. This is gonna be a chill, relaxed, lo-fi type of vibe. Speaking of, I should turn on some music. I changed the audio settings yet again because now I'm using like the ASIO route for audio. So this might be different now. Do let me know if the music is too loud or whatever, because everything changed once more. Whew. Okay, this is gonna be an interesting stream. I'm pretty sure I'm still got a little bit of high left. But I think I can focus. As long as people can realign me whenever I get stuck on something. Okay. Realigning my mind. Uber Spread was a good reminder of drinking water last time, so if somebody wants to sign up for that, feel free to. I'm really bad at remembering to drink water. I feel like I should have at least 1 glass of water per hour or something. But I think I average like 1 glass of water per 4 hours. Oh, you watched Minority Report? That was a long time ago I saw that movie. I just remember that was like a lot of people in VR saw that movie as like an inspiration thing because of the way that he like handled UI with his hands or whatever. It's always like referenced in so many like VR talks, especially when it comes to hand interactions and whatnot. Sorry. The Minority Report had like a scene where whoever was the lead, I think, was doing a lot of like finger gestures to like move a bunch of UI around, like those hand interactions. It was also one of those like futuristic movies where they had like transparent displays for some reason. Like, why would you have an alpha channel in displays? That seems garbage. And everything is like tinted blue or whatever. Even though it's super futuristic, they have to manually transfer files from one screen to the next. Wait, but that seems really good though. Or wait, what would be the alternative? Because like these days, you can't even do that. Like in reality, you have to use a USB stick or send it over some sort of slow network where you need an account and where you need to log in on both devices to transfer the thing, and it's like very cumbersome and strange. This is the future. Can I just send a file easily? Well, no. I mean, the future is today compared to like 20 years ago, and it's still not convenient. So yeah, it's not ever going to be convenient. After using the HoloLens, I think all gesture-based interactions is a bit too much. Gotcha. What headphones do you have? AKG K702, I think. Right. Actually, I did set up a link now. So below the stream, there's a under the what tools I use, added a link to my streaming setup, which includes like what headphones I'm using and whatnot. So yeah, feel free to click that one in case you want to know about the setup or whatever devices I'm using, like webcam and mic and whatnot. Okay, for those of you in chat, what do you want to learn from the procedural geometry thing? I think I'm gonna go through the very basics of how to define a mesh in code, which kind of also means that I need to go through how a mesh is structured. So I'm gonna start with that, and then we're gonna create a quad from code, which is gonna be pretty straightforward. And then I'm thinking we should make something more advanced. And since I like Bezier curves so much, I'm probably just gonna do that. So make like a mesh that's extruded along a curve or something. Because I've talked about that a lot, and I'll probably be able to do that even while I have this like lingering high right now. So that's probably gonna work out, I think. But yeah, is there anything you want me to go through specifically that I might miss with that plan? One thing I'm not gonna do is I'm not gonna do any like generating a mesh based on some like field data, like marching cubes or whatever. I'm not gonna do any of that stuff because I don't know enough about it to do that. I have no idea what this is even. Is that a shader? Is that like procedural generation? In this case, it's basically modeling through code, which means that you can quite often make stuff that's more dynamic than things you model just manually in whatever modeling application you have. So what we're going to do is to create meshes through code in Unity and probably create something dynamic in the end with the Bezier curves. That's the plan. It doesn't have to be a shader. You could do a bunch of things where you could do a bunch of shaders that help you generate the shape you want, which incidentally I've done in the game that I'm working on, but I don't know if we're gonna get to that tonight, today. Wait, this is morning right now. Did a catalog coding hex scheme mesh tutorial a while ago. Interested to see if there's a better way to structure and compartmentalize mesh creation with different features. Gotcha. Once we learn how to make a quad, how easy will it be to generate a cube? It'll be pretty straightforward, yeah. If you want, we can do both. We can do a quad and then we do a cube. I think there are some concepts that, like after you've learned the basics, I think generating anything after that is going to be pretty straightforward. Then the tricky part is going to be in like setting up that generation code and like what order you should set up everything when it comes to like vertices and triangles. That can be pretty messy sometimes depending on what it is that you're generating. Because quite often you need to keep track of indices and whatnot in ways that you might not have done before. But yeah, generally it should be pretty straightforward. Okay, so in this tutorial, we're gonna go through how to generate meshes in Unity. I think we're gonna start, towards the end, we're probably gonna do generating meshes along a spline because I cannot help myself making Bezier curves. So we're gonna go through the structure of meshes, how those are set up, what vertices are, what triangles are and whatnot. And then we're gonna generate a quad in Unity, just make a simple quad, and then, kind of get an idea of how you generate meshes like that. And then from there, maybe we can make a cube if you want to. That's probably going to be a bit tedious, but but it's going to work out. And then after that, we're probably going to do extruding a 2D shape along a spline. That's the plan. Hope that sounds good. But first off, we need to explain meshes. Like what are meshes? How are they structured? And so forth. And that's really relevant because when you model things in like Maya or Max or whatever, you don't really have to know about all the intricate details of like how data is stored in meshes. But when we're generating them from code, we really have to. We have to know, how our triangles set up explicitly. It's a very specific process. And yeah, so we need to be precise with these things and have a good understanding of how all of this is structured. So let's talk about meshes. So the very basics of a mesh is that you have a set of vertices, right? And the vertices generally, depending on your definition of vertex and the context and whatnot, you can either see them only as positions in space, relative to the space of, whatever mesh you have, right? So you can see them either as positions or data containers of more features than just positions. But anyway, vertices, I usually like to think of vertices as things containing a bunch of different properties like position, a normal, a UV, a tangent, and so forth, right? So each of these vertices has all of that data. And then there are two things. We have vertices and then we have triangles. So triangles are usually what has the connectivity information for how these are connected. So here's one triangle and then we can make another one. And then we can make a last one right here. Measure 3D/2D grid. All of this is 3D. I'm not sure what you mean. So anyway, yeah. So basically, we got the vertices. These have a position and all of those properties, and then you have the triangles, and the triangles define how these are connected. And that kind of makes sense. I think a lot of you probably already knew that. Then the question is like, how is that data defined in a mesh, like explicitly? Like if you were to generate this through code, how do you connect these vertices? How do you even define them? So what we're going to do is that we're going to make a very simple quad. So a quad is generally two triangles where you have four vertices, you have one in each corner, and then these are connected by two triangles. It's a very, very straightforward, simple little mesh, very useful, and it's used for pretty much every the particle systems use quads. It's a very simple way to, have a simple texture float around, like, little glowy sprites or whatever. Okay. So let's look into how to make a quad in Unity. So I'm going to switch to Unity. Let's see if I can make a script. There we go. It's going to be called proc_geo. Now I want to generate a mesh in this one. So how do we do that? Well, first off, if we want to generate this mesh, it's probably a good idea to be able to debug and inspect that we actually have generated a mesh. Probably the easiest way of doing that is to make an object where your script resides, and then you add a mesh filter and a mesh renderer. So then as soon as we generate that mesh, we assign them to to the mesh filter, right? And then we can also specify the material. So in this case, I'm just going to use the default material. And then the mesh, I'm just going to leave that field empty because that's where we're going to create a mesh and then assign to that field in the mesh filter. All right, so let's do that in the awake function. Okay, so what are we going to do now? We're going to create a mesh, right? So you simply start by making an instance of a mesh, right? Triangle must be all right or left side connected for visibility, or is it different for game engine? That's usually called winding order, and that's the order in which you connect the vertices for every triangle matters quite a lot. We're gonna go into that very, very soon. All right, so we're gonna create a mesh now. So we're just gonna create a variable called mesh. Mesh equals new mesh. I think we can, no, we can't. Okay, we need to, I usually like to supply a name to the mesh as well. Because that way it has it says something in the inspector, right? There we go. Cool. So now we created a mesh. That's it. We're done. That's how you make a mesh. But we probably want some triangles and vertices in this, right? So let's go to this one again. Okay, so a quad is generally in 2D space, or well, every vertex is in 3D space, but we can just give them 2D coordinates, and they're going to be on the XY axis, right? So the question we need to answer first is where do we want our pivot to be? I think I want the pivot to be in the center, so that's going to be 0, 0, and you have the axes going out here. And then I'm just going to give these very, very simple coordinates. So I'm probably going to make this one 1, 1. This one is going to be 0, or no, -1, 1. And this one is going to be -1, -1. And this coordinate's going to be 1 and -1. So we have x and y, right? So these are the coordinates for every vertex. So that's what we're going to do for the quad. So the way you define vertices in a mesh is either through a list of vector 3 or an array of vector 3. It depends on how you want to do it. I think if you update the mesh every frame, you might want to use a different method because I think some of those generate garbage, some of them don't. So it kind of depends on how you want to assign to it. Excuse me. All right, so first we need to define the vertices. So let's make a list of vector 3. We're gonna call it verts. Maybe we should be more explicit. This is the points, right? Because again, I like to think of vertices as data containers, not just points in and of themselves. Right, so this is gonna be points. So we're gonna make a new vector 3 list, and then we're gonna supply the points in here, right? Is it kosher to post links? As long as you're not spamming irrelevant things, if it's related to things you're talking about, then sure. I'm probably not going to look at the links while I'm explaining something though. But yeah, you can post links. All right. So let's do these vertices here. All right. Okay, so the order in which we define these matters quite a lot when we do the triangles. So we probably want to give these an index each. So let's remember that. So we're going to make this 0. We're going to make this 1. We're going to make this 2. And we're going to make this 3. Array index 0, 1, 2, 3, right? All right, so then we can put that one there, docs and windows. There we go. I hope that's still readable. All right, so the 0, we can do vector 2s because why not? Actually, I think the constructor vector 3 does support 2 elements. Yeah, good. So we want -1, 1, And then go to the next, and we need 4 of these, right? The next one is 1, 1, and then we have -1, -1, and then 1, -1. There we go. But I usually like to align things like this because it looks pretty. Right. Okay, so now we have the vertices set up for this mesh, or the the point or the location of each vertex. So in this case, we have 4 vertices, and that's all ready to be connected with triangles. Okay, so how do we define triangles? The way you define triangles can be a bit strange because it's a very odd way to assign things, but it'll make sense. So, all right, so if you have a triangle, you probably know that you have to connect 3 vertices in a single triangle, right? So, so how do we do this? Let's say we have these 3 vertices, and then we want to connect a triangle to fill this face, right? So this should be a triangle. If you can imagine this being like a perspective drawing, we probably want the triangle to face a specific direction, right? Like we probably want it to face this direction, and we don't want it to face the other direction, because if we have a shader with backface culling, if it's pointing this direction, then it's going to be flipped, right? So we need to define this in the correct order. So the way it works is that the order in which you define the vertices give you the direction of this one. So if you define it in this order, where you do this one first, then this one, and then this one, the normal is going to point upwards. If you reverse that and do this one first, then this one, and then this one, it's going to point downwards. So if you want a rule of thumb for this, this depends on your coordinate system and whatnot, but in Unity, Unity is a left-handed coordinate system. So if you use your left hand and then curl it up, you can kind of see that your fingers create like a curl direction. So if you use the left hand to do that, your thumb is the normal of the triangle. So that's a very good like rule of thumb for thinking about what direction the face will point when you define triangles. And again, this depends on where you do this, but the winding order in Unity for meshes is left-handed, curl your fingers, and then your thumb is normal. So the way you define triangles is actually straight up through these numbers right here. So these are the indices for the vertices. So if you want to define 2 triangles for this one, we need to remember these numbers. So let's say we're going to do these 2 triangles, and we want the normal to face towards us, right? So if we want to define this triangle right here, we need to go in this order. So we need to go like this, right? Okay, so then oh heck, sorry, thank you. Imagine that it was thumbs up for me joining. Well, why not? Also, hello, Kashade. How are you doing? I hope you're doing well. Thank you, Alsar, for this scene thing. Right. Okay. So so we need to define things through these indices that we have right here. So when we define a triangle, each triangle is simply is simply 3 numbers for the index of each vertex in the each vertex in the triangle. So if we want to make this quad where the normals are pointing towards us, then using the left-handed rule. Thank you so much for the subscription, Akashanen. I don't know how to pronounce the name, but thank you so much. The heck, Kryptonite. Why all of these sudden Prime subs? Thank you so much. That is super nice of y'all. All right, so just Aka is fine. Gotcha. All right, so now we need to define these triangles. We have the triangle order based on these indices. So the first triangle, we want to go from this one. So it's going to go from this to this one, and then from this one to this one. So that gives us the indices 2, 0, and 1. So 2, 0, 1 is going to be our first triangle. So these numbers, I usually refer to them as just triangle indices because they're not like explicitly referring to, the objects of the vertex. It's just these numbers, right? So for the triangles, we now have the first triangle of 2, 0, and 1. So this is our first triangle. And then the second triangle, again, we need to go clockwise if we want the normal to point towards the camera in this case. So then we need to go 2, 1, 3. So in this case, for the second triangle, we go 2, 1, 3. So that's the order we need to go there. So if we go back to Unity now, actually I probably should dock these next to each other again. All right, so we got our vertices. Now we need to do the triangles. So as you can see, these are just indices. So the triangles are actually just int arrays. So this is going to be our triangle indices. There we go. And then that's going to be a new integer array. Then in here we define our triangles. So I usually like to group them, one triangle per line for simple meshes like this. So in this case, it's 2, 0, 1 for the first triangle, and then we do 2, 1, 3 for the second triangle. So there we go. So now we've got the triangles defined for this very, very simple quad. Okay. And then we need to assign this to the mesh, right? So right now we just have these like two loose arrays of items, right? But we haven't like actually assigned this to the mesh at all. So let's assign it to the mesh and see what happens. So to do that, we do mesh dot vertices. Actually, we might need to use set vertices in this case. Because set vertices takes a list and dot vertices takes an array, and we have a list now. So we're going to send our points there, and then that should be it. So now we're setting the vertices, and then we want to set the triangles. So then we do mesh dot triangles equals, and then we send it the triangle indices. There we go. So we've now got a very simple setup to set up a quad in Unity. There are a few other things that we haven't set, but we're going to get to that pretty soon. All right, so now that we've done that, is there anything else we need to do? We need to apply the mesh. Or no, I'm thinking of textures now. We don't need to apply meshes. Pretty sure that should be it. Is mesh a Unity class? Yep, mesh is a Unity class. Right, we need to assign it to the mesh filter. Right. So we do get components, mesh filter, and then we do dot shared mesh equals mesh. All right. Does mesh.triangles just make every 3 ints a triangle in that array? Yeah, it does. So every group of 3 is going to be one single triangle. Why assign it to the mesh filter? Because we want to be able to debug this and see this mesh in the scene, right? Otherwise, if we don't do that, we don't see it. We just have it in data in memory, but there's no way to inspect the mesh, right? Thank you for the follow. Any reason why it's 2 units across? I just wanted to do that because I wanted to have simple values here. I don't want to have a bunch of 0.5 in decimals because it looks shitty. I mean, it just depends on how you want to set up the mesh, depending on your use case, right? Okay, so let's see if this works. What if it has less than 3 ints in the array? Does it throw an error? Probably, yeah. I haven't tried doing that, but... Alright. Let's see. What happened? I didn't recompile the scripts. Alright, there we go. I also want to dock these because I don't really care about the game view. Alright, let's move this to 0. And then we hit play. There we go. Now we've got a procedurally generated mesh. And I should probably turn on wire in case you want to look at the wireframe. So now we've created this very, very simple quad. So this is our mesh that we created. And you can see it in the mesh inspector up here. This is the procedural quad. If I double click that, you can see the inspector for this too. And this is the mesh that we created. It says 4 verts and 2 triangles. That is very accurate. All right. So there's probably one more thing that we want to do with this. So you might have noticed, or I'm actually not sure if it's noticeable. I don't know how it handles like default values for this, but this mesh currently doesn't have any normals. how the vertices connect to both triangles. Basically, the triangles are just indices. So if you want to connect this vertex to this vertex to this vertex with a triangle, you define that using the vertex index. So this is vertex number 0, this is vertex number 1, and so forth. And if you want to define a triangle, you say, I want a triangle from vertex 2, 0, and 1. And then that's the way you connect vertices with triangles. So that's what we did for this one. All right. Strictly speaking, none of the triangles are ever connected. Not sure what you mean, or they're just generated using similar verts. Sometimes the same vertices. It usually depends on whether or not you have it split in the data per vertex, right? I know, but both triangles are connected. How do I know the vertices are merged? The way vertices are merged is that you only have a single vertex here. If you want to make something that is hard-edged, for instance, then you need to split this vertex into multiple vertices. But in this case, they are quote-unquote connected because this vertex has the same data, going out across this triangle as this triangle, right? But if this vertex right here was split in two, then if it was split in two, then one triangle would have a different set of data, and it would look different in this area compared to this one, right? A very common use case for that is for normals. So if you have a hard edge, for instance, then that means that you have two normals, and then that splits the vertex, right? Vertices can split for a number of reasons. Usually it's either normals or UV seams that splits triangles. That's the most common case. So quite often if you have a cube, for instance, so I'm just gonna quickly make a pseudo perspective cube. There we go. So if you have this cube, for instance, you might ask yourself, how many vertices does this have? And the answer is that it's not just the vertices that you see here generally, right? So you might say that, oh, this is probably 8 vertices, right? Because you've got one vertex in each corner of this cube. But in reality, if there's a hard edge on this one, then you need multiple vertices here. And the reason for that is because this face right here on top of the cube, this one needs a normal that is pointing in a specific direction. So this face needs to have a normal pointing upwards, but this face on the front right here needs a normal that is pointing out from that face. And then the face in the back here, that one needs a third normal that is pointing, away from the screen in this direction, right? And there's no way for a single vertex to have multiple normals. So what happens is that you have an additional vertex. So a cube that has hard edges actually doesn't have 8 vertices technically. It has 8 times 3 vertices, which is something. I don't know how to do math. 24? I don't know. All right. Okay, so could normal be an attribute to a face? No, faces don't really contain data at all. You have data in your vertices, and then you have the connectivity of the triangles. And then if you want something like the face normal, that data is just in, having the triangle be defined in a specific order tells you that the face is pointing in a specific direction according to the left-hand rule, right? Yeah. All right. In Unity, you mean? I think so. Did I not say Unity? Anyway, so right now we don't have normals defined for this one. Generally, you want to have that so that you can get like correct lighting and whatnot. I think if we just right now put a point light here, it actually looks very broken, right? So if we have the light source above the surface, we get no reflections. If the light source is below the surface, we do get like this highlight here. So everything is very strange, right? And that's because we haven't defined the normals of this one. So we need to do that. There are multiple ways of doing that. Probably the easiest one is to recalculate them using a Unity function. So if you want to do that, you can do mesh.recalculate normals, not that one. So recalculate normals kind of does a bunch of guesswork and generates normals for you based on the geometry, which is quite often enough for many use cases. But in some cases, you want to explicitly define the normals. So if you have very like performance sensitive code, you might want to do that on your own, right? Instead of letting Unity recalculate the normals from scratch. So, but in this case, we can try using that, and then we restart to generate a new mesh. And then I didn't recompile the code because I just keep forgetting to do that. It should also add the light source. There we go. Great. Okay, so here is our quad again. Let's see if it's better this time. It is not. Did it fail to recalculate the normals? Now I'm actually very confused. Does it not work because we don't have a normals array or something? Maybe recalc after assign. That shouldn't matter. Oh wait, oh right, after assigning these two. That's true. Heck, sorry, I forgot about that. I thought you meant assign to the mesh filter. Apologies. All right, that should work. There we go. Move the light source. That's a very bright light source. Probably because I have a directional light in the scene too. Turn that off. And there we go. This is more what we'd expect, right? So now we have this little proper shading on this one, right? So maybe we should make a way to debug this, because sometimes it's difficult to see if things are correct, right? So I'm just going to quickly create a shader for that. Let's see. Let's do a normal debugging shader. Normal, and then this is not a shader tutorial. Do you want T or not? I don't know. Debug how? Like drawing gizmos to display the normals? I'm thinking display them as a color, which is quite useful when you're doing for shaders and whatnot. So I can just apply this shader and then I can see a color for the direction that the normal is pointing, which is pretty useful. So I'm just making this quick shader to debug that. Did I call it normal or normals? Normal. All right. There we go. Okay. Should probably normalize that too. Like applying the normal map as a texture. It's not really a normal map. It's just a, so this is just the normal direction of each vertex, and then that's interpolated across each triangle. So there we go. Right. That's incorrect. I don't have a material. I need a material. Ah, geez. We probably got negative normals on this one. Right, because the normal is pointing to negative z, so this one is just not visible right now. But we can, if we put it on a different mesh, we can make sure that the shader works at first. So if we make a sphere, and then we slap on the normal direction. So now the color of this one corresponds to the gizmo in the top right. So if the normal is pointing upwards, it should be green because that's along the positive y-axis. If it's pointing along the z-axis, it's blue, and so forth, right? And then the x-axis is red. So this is a pretty useful way to make sure that, to debug your normals, if your normals were generated correctly. For this quad though, it's pointing in the negative z direction, which is not entirely useful because then it's just pitch black, right? But maybe we want this to be defined in the other direction so that the z-axis of this object is also the normal of the surface, which would probably be a pretty good thing to do. So if we want to do that, all we need to do is to reverse the triangle indices. Because remember, the winding order defines the direction that the normal is pointing of the face, right? So that's how the face normal is generated. So if we just flip the order of this one, we move place between the first and last index of each triangle, like this. And now that should flip the mesh. So if we now restart, there we go. Why did I switch to 2D? So now it's fully blue. That means that the normal is correct. The normals currently are in local space, so it's always blue regardless of the rotation of this one. But that's probably good because we probably want to debug the local space values because everything we assign to a mesh here is going to be in local space. You know, it's all of the points are local space, all of the triangles, or not the triangles, they don't have a space, but the normals are in local space and whatnot. So it's in the space of the mesh. And then the transforming things to world space, that's done by shaders generally, depending on how you set your scene up and whatnot. But yeah. All right. So anyway, let's say we do want to define these manually and we don't want to use recalculate normals. In case we want this code to be faster and more efficient, then we should probably not use recalculate normals because that one is doing a lot of math to, you know, figure out the normals per vertex. So yeah, so instead we're going to explicitly give this one normals. Normals is very similar to points. You have a list of vector 3s, and each vector is the direction of the normal, right? And again, you do the same layout as with the points. If we have 4 vertices in our mesh, we need 4 points, and we need 4 normals, right? So we're going to make a normals array, or a list, I suppose. There we go. And then we want all of these to point along the z-axis, right? So let's do that. Local is also called model space sometimes, or on confusing things. They're the same thing in this case, yeah. So they're equivalent. Okay, so let's just give it normals. So then we would say for each of these, we can just do vector3.forward if we want to, which is equivalent to new vector3 001. That's the direction we want it to point in, right? Because that's the positive z-axis, and that's where we want them to point. So yeah, that should be it for each of these, each vertex, right? So now we have these normals, and instead of doing recalculate normals, we do mesh dot set normals, and then we give them mesh these normals right here. There we go. Might actually rip this off. That's the whole point of a tutorial. Please rip everything off. All right. Okay. Did that make sense so far, by the way? Is there anything that you think was a bit unclear in terms of how normals work and whatnot? I hope we're so far so good. Also, we should probably make sure that this code works before I celebrate it. All right. Slap on the normals, and they still work. Good. Are the normals mapped one-to-one with a vert list or triangle list? What happens if you build a triangle with opposing normals in the verts? So, okay, this is probably a good opportunity to talk about interpolation. I did that last stream for the shader tutorial, but this is a new tutorial, so we're going to go over that. So, if you, I think it's easier to think about this in a 2D context. So let's say we have we're looking at the cut through, or the cutout, what's it called? A slice of something. There's a term for this, but I totally forgot. So cross-section, that's the one. So let's say we're looking at the cross-section of a mesh, then every face is just going to be a line, right? So let's say we have these vertices right here, and then we have triangles defined here, right? So this is a 2D mesh now. Also, thank you for the follow. Right, okay, so we've got these triangles defined here, and then you can imagine this being a 3D mesh, right? So it would like extend into the depth here, if that makes sense. There we go. Maybe this is easier to conceptualize. So that's a very tapered section. All right, here we go. Now we got a mesh. It's a simple edge right here, and you would probably have 4 triangles on this whole thing, right? Okay, so how would you define? I'm just gonna remove these because they're not gonna help. Okay, so looking at from the side on a mesh, as we talked about, we define a position for each vertex. And again, that's in model space. So that would just be like a vector pointing from from the origin of the mesh to that one, right? So then the coordinate of this one would, be this X position and this Y position, right? So that's the position of each vertex, although in 3D and not 2D. Okay, the next thing we talked about was normals, right? So a normal is a normalized vector that is pointing in a specific direction per vertex. And this is used to define what should be smooth shading and what should be hard edge shading, right? So the way it works is that if this edge right here, if we want this to be a soft edge, as in the shading of this edge should look as if it's this soft edge like this. That's quite often used for like if you want to make a cylinder, for instance, the cylinder is supposed to have very soft edges right here, but in the mesh you're gonna have like discrete points here, but you want the shading on this to be smooth, right? So if you do that, then the way smoothing is defined in these meshes is that the normals you have here, these normals of these is that you're going to have a normal that's pointing in this direction, and then down here you're going to have a normal that's pointing in this direction right here. So it kind of just tells you that, this is the direction I want the face to look as if it's facing, right? So what happens between these is that the normal is interpolated. So if you want to get the normal here, well, that's going to be like a halfway blend between these two. So then you're going to get a vector that is slightly leaning to the left, right, in here. And then it's going to lean more and more to the left the closer you get to this one. One thing to note is that you need to normalize this one in case you want to use it in the fragment shader, because this one is... Because it's interpolated between 2 normals, it's not going to have the length of 1. So, yeah. Oh, wait, is the music strange? Yeah, that does look strange. Why is it panned that way? Hold on. That is very strange. I actually have no idea why the music would do that. Okay, maybe I should look into that. I'm trying to think of what that could be. Heck, my audio setup is such a mess right now. Okay, I'm gonna replug the music. I'll be right back. What? Do you want tea? I do, but I'm very warm. So I don't know how to balance those two. Yeah. Thanks, though.
Sweet yes or no?
No, I'm too warm. Iced tea. Is the music good now? It looks good on my end. I have no idea why it like shifted to one of the panning sort of targets. What's it called? One of the channels. If you want to have a model look hardened, having the faces clearly visible like a low poly model, would it be something you would do with the normals on the vertices, or would that be something you would do with the shaders to make it look not smooth? There are different ways of setting that up. So the very easiest way of doing that is simply to split each vertex. I'm going to show you what that looks like. So Okay, so we talked about this, that if you want to make something look smooth shaded, right? You have a single normal, and then both of these triangles use the same vertex here, right? So if you go to this section right here, this one is going to do the same. The normals are going to be interpolated across this line right here. So they're going to, face more and more towards the same direction as the final vert down there. The end result is that the shading you get when looking at this surface is that it approximates a smooth shape like this. Because this normal right here is the normal this surface would have in case it actually had that shape, right? So that's the way you do soft edges. But let's say you don't want to do that. Let's say, wait, what happened to my... Oh, heck. That's some tea. What happened to my... I got like a pop in my audio when you turned off the lights. So I was like worried that the music would be gone again, but I think we're fine. Okay, so if we want to make this a hard edge, we actually have to have multiple vertices there. So if we undo this again, then we have to have two vertices here. So instead of just a single one, we have two vertices with the exact same position. Photoshop, stop this. So if we do that, then we can have two normals, right? We can have one normal that is pointing in the same direction as this face right here, and then we have a second normal that is pointing the same way as the normal down here, right? So if we do that, then then they're not going to interpolate here anymore. So, well, they are going to interpolate, but they have the same value. So all of these are going to point in the same direction. And then as soon as you see this face instead of this face, the normal is going to have a harsh cutoff where it like snaps to the other direction, right? So that's kind of how you make hard edges. But but basically what happens here is that it's going to be two vertices here, and that's why a cube with hard edges simply just doesn't have, it doesn't have 8 normals, it doesn't have 8 positions, it has 24, I think, of all of these, right? Because it has to like duplicate each vertex at the corners. Yeah, so that's how that works. I knew we'd get a tutorial on edging. But yeah, so now you know how to do edging. All right. Anyway, so similarly, we haven't talked about UVs. Maybe I should do that. What if you want to move the vertex? Will it get separated? It depends on where you're moving it, but generally, yeah. So if you do want to move this vertex, then yeah, these are two vertices. If you want to move them, you have to move both of them, right? So for instance, if you have a shader where you want to like, move each vertex along their normal, if you do that, then what's going to happen is that, you're going to have one vertex that moved all the way here and one that moved all the way here. And then if you do that, then, well, your mesh now has a gap in it. So because it's not going to be connected anymore, because the shader moved them along the normals, and these two vertices have two separate and diverging normals. So that's just going to get a split like this, right? So yeah, if you do want to move the vertex either through a shader or through code, you need to make sure that you move both of them, which is easy enough to do in C# code because you can keep track of, what vertices are at the same position. But in shader code, there's no way to access your neighboring vertices unless you make a geometry shader. I'm pretty sure you can do that in like one of those geometry hole shader, domain and hole shaders. But yeah. Anyway, yeah. Did that make sense? I'm not sure if that answered your question. Okay, I need water. I need to drink water. Oh yeah, and for those of you who don't know, feel free to ask questions at any time. Like if I'm being unclear or you're curious about something, then just go ahead and ask. I'm just happy to answer. Oh heck, I didn't know Bomb Mask was still here. Hope you're doing well. Alright. Right, I was gonna go through another example of where this happens. So So okay, we were talking about you know all the data of a vertex, right? So you have a vertex, and there are several things in this one, right? Quite often, people use vertex and vertex position synonymously, but usually, like I mentioned, I usually like to think of vertices as data containers. So a vertex has a position, it has a normal, as we mentioned, right? So it has a position, has a normal, and then it has a bunch of other things. And this kind of depends on, you know, how you read the data from this shader, how you define the shader in, you know, whatever you made the shader in, or the whatever you made the mesh in, right? So one more very common thing is to also have UV coordinates. So UV coordinates are usually 2D coordinates along your mesh that is quite often used for mapping textures onto your 3D mesh, right? So UV coordinates can also cause this split right here. So let's say you have a texture that you map onto this one, but then you want a different part of the texture, like say you have a full texture like this, you want this segment right here to go on this side, and you want this segment right here to go on this side. So you kind of like flip the texture. Well, then what's going to happen is that you need to make a split in the coordinates for this. So if you do that, then again, each vertex can only have one UV, can only have one normal, and so forth, right? So as soon as you need two coordinates, two UV coordinates per vertex, that's going to create a duplicate set of vertices here, because you just have to duplicate it, because the vertex can only have a single UV coordinate and so forth. So if we, for instance, make a mesh in Maya, just make a very simple mesh, and then if we make a split in this one, and then we go to the UV coordinates. So this is kind of an overview of the UV coordinates of this mesh. So, and UV coordinates are just 2D coordinates, and I can move this around, and that would change, you know, how textures are mapped to this object. So currently, if you look at each vertex here in the corner, then these have the same UV coordinate, right? And if I move this one, it's going to move both of them. So this is now just a single vertex, because they all have the same normal, the same everything, right? So yeah, if I export this mesh right now, it would probably have 6 vertices. Also, thank you for the follow, many arf. But if we want to split this in the UV coordinates, so let's say we select that one and then we cut it, then now we've separated these. So if you look at the, you know, the physical vertex right here, then this one now has 2 UV coordinates, right? So a single vertex has 2 UV coordinates, which again, that means that you've now split this vertex into multiple vertices. So that means that it's going to have a duplicate set of position, duplicate set of normals, and so forth as well. So if we save this mesh is not going to have 6 vertices. This mesh is going to have 8 vertices, right? Because we've now duplicated the vertex in each of these corners. So whenever you have hard edges in a mesh, whenever you have a lot of UV seams and separate shells, you're going to get more and more vertices when you do that. So it can be, sometimes it's pretty useful to know about that. So yeah, so if you have some sort of data mesh where you just want to define a volume or a region or something, it can be pretty useful to like always merge every vertex, always unify, always soft shade all the normals, always merge all the UVs into a single point, like combine all the data so that you have as few vertices as possible in the thing. Does having many UV shells affect performance? It affects performance to the degree that you split vertices. It probably doesn't affect it that much, but again, you do get more vertices. You don't get more triangles though, but yeah. I guess it also depends on your shader, if you're doing a lot of stuff in the vertex shader and so forth, but yeah. I don't think it's generally something that people tend to optimize for. I think there are usually other things that have a higher priority than like reducing the amount of UV shells. Yeah. If anything, I think the one thing that happens is that your mesh becomes bigger in terms of like data size, but who cares about that? Also, thank you for the follow. Also worth noting, I figured out that most GPU limits verts per mesh at around 65K. Gotcha. Yeah. I think Unity has a few internal systems that like splits the mesh up in case you use too many vertices. But yeah. Mr. Pumpkin Sword, thank you for the follow, and that's a nice nickname. All right. I hope things make sense so far. Should we do UV coordinates for this mesh too? So we can like map a texture to it? Not as far as I know, blue passive earth limit, I just started ignoring them. Gotcha. Alright. Alright. So let's do UVs. I feel like UVs is very important to know. So maybe we should make one more debug material so that we can debug the UVs. Actually, let's keep that. It's not going to matter in this case. Alright, there we go. So, let's now create a sphere. So now we have a way to debug the UV coordinates of this one. So now each color corresponds to a 2D coordinates, right? If we want to look at the, X coordinate of the UVs, then we can do dot X. And if we do that, then we get a syntax error because I messed up. There we go. So now we're inspecting the X coordinate of each vertex, right? So you can see that this one is like going up and up and up around the object. So we can assume that the UVs for the sphere goes to the left in UV coordinate space, right? Or to the right. Yeah, and then same thing for the Y coordinate or the V coordinate, I suppose. So that now this one is just, 0 at the bottom, then increasing as it goes towards the top. And then if we visualize them together, then that's when we get this like very mango colored thing. Yeah, so now we're kind of visualizing the UVs of this one. Okay, so if we swap this out with the Unity's quad, we can kind of see what we want our thing to look like in the end. So this is kind of the reference. This is what our quad should look like when we generate them. Because this is simply 0, 0 in the bottom left, it's 0, 1 in the top left, and so forth, right? Mango shader tutorial part 1. Yeah. Anyway, cool. So let's go to our mesh again. This is not the mesh. Can't unsee mango. Nope. That's fine. It's a nice set of colors though. Okay, so now we want to generate the UVs for this one. So okay, so thinking again about the coordinates here. So we have 4 UVs, right? So we're not going to do negative numbers here. This one is going to go from 0 to 1 instead of negative 1 to 1, right? All right, so let's just make the UVs. So that would just be a vector 2 list. So this would be our UVs, new list vector 2. And then in here, that's where we can now define each UV coordinate. So that's going to be a new vector 2. Okay. So let's see. If we go to, let's see. Where did our, right, I want to go to Photoshop, not Unity. All right. I think I might be getting these flipped now because the normals are pointing the other direction. So I need to like reverse my head to make sure that I get this right. Because I think I want to flip this horizontally now. So okay, so say you want to generate the UVs now, then I think the first UV would be this one right here, but we want this to be flipped to the other side. Actually, let's not do the flipping. Let's just pretend that's not happening. So then it's 0, 1 for the first one. So that's this corner right here. We want X to be 0, that's on the X coordinate. And we want Y to be 1, because it's all, we all want it to be, like, we want 0 to be here, right? Okay, so 0 here, and then that should extend up here. Okay, so then the next one is this vertex right here. This one should be 1, 1, because both X and Y is 1. Then we go to the next. And this one is this right here. So that should be 0, 0. That's our origin. And then we go to apparently the bottom of the script, because I hit the wrong keys, to this one right here, and that should be x1 and y0. And that should be it for the UVs. We might have to flip these horizontally, because we reversed the normals from our sketch. So, okay, now we do mesh.set UVs. Then we need to specify what UV channel to assign to. Generally, you only have like 1, sometimes 2 channels, depending on how you set up your shaders. But we're just going to assign to channel 0 for now. And then we assign the UVs, or from the UV array. And that should be it to set up the UVs for this mesh. So let's go back to Unity, and let's see if our mesh is going to look the same. And there we go. And then we assign the mango shader. And that looks very incorrect. Did I not recompile the code? I didn't recompile the code. I forgot to recompile. This happens way too often. Let's assign the mango immediately. If I can hit this. There we go. There we go. All right, so this seems to work. And as I mentioned, this one is now flipped because we flipped the direction of each face, right? So now this one is kind of horizontally flipped. So let's flip it back. So that simply means that the x coordinate should be reversed. So we're going to do 1, 1, 0, 0. Then go back to Unity, restart. Ripe. Yep. Where did I hit play twice? There we go. All right. So now we procedurally generated a mesh, or a very simple quad with the correct normals. It's got UVs. It's got everything you might want in this world. I guess it doesn't really match Unity's quad yet, because Unity's quad is, I think it's got 1 in size. There we go. Oh, and their quad is pointing to the negative z-axis. That's bizarre. But yeah. Anyway, so ours is like twice as big, but we can change that if we want to. You know, all we need to do is like multiply this by 0.5, or we do that in each of these. But it looks messy. I don't like having to insert a bunch of 0.5 everywhere. Now procedurally generate a mesh of a human. I will not be able to do that. Oh, that was the UVs. Never mind. Hold on. Hold up. There we go. Very, very low poly human. I mean, maybe this is a very low poly human, right? All right. Should we start generating something more complex? Yeah, let's do that. Okay, thank you for the follow, Dutchmania. Alright. So far this is kind of like, oh great, we generated a quad, we already have that in Unity. What's the big deal? What's the purpose of this? Let's do something exciting. Or maybe not exciting. I don't know if we should do that yet. How should we proceed? Oh, okay, here's the thing we can do. How about this? We want to yeah, let's make a procedural mesh where it's a ring, or it's kind of like quad strip but in a ring. So let's say you have an object in Unity, you know, this is the pivot, and then we're gonna make a script that can generate a kind of like a quad strip ring like this, where you have a bunch of vertices, like so. There we go. And then it's gonna do a shape like this. And then it's also going to be dynamic. So the idea is that you should be able to specify the inner and outer radius, and then you should be able to specify the detail level of this one. So you can make it, you know, you can specify how smooth you want it to be, right? And then it would generate the triangle sort of like this. Does that make sense? Would that be an interesting example, you think? This could be applicable for a bunch of things. Like if you want to generate like light cones or something or whatever, then this would be, it would be something like this, right? Okay, all right. Yeah, let's do that then. I hope my high is faded enough so that I can think about the indexing and math of this now. All right, let's rename this one. This is going to be our quad generator. Thank you for the follow, Maxi Alpha. That one just didn't load. You can make a spotlight mesh to shine onto the low poly mango. I can do that, yeah. Those are the things that we can do with the power of mesh generation. All right. Should this be, never mind, no. I'm not gonna ask that question. All right, what do we call this one? This is gonna be like a quad strip ring, quad ring. Quad ring. Let's call it quad ring. That's probably good. Torus. We're not really gonna make a torus out of this. It's kind of like a 2D equivalent of a torus. So it's like a paper ring, pretty much, yeah. Okay, cool. We now got our quad ring. So a flat torus, sure. 2D torus. A 2D torus is, I feel like that kind of works as a definition, right? No, probably not, because then a 3D torus would be a sphere with a hole inside of it. I don't know. It's anyway, halo, sure. I'm gonna call it a quad ring. That's good enough for me. Okay, so what did we want here? So for the for this one, we wanted to have a few parameters, right? We wanted to have a we want to have an inner radius, right? So that's going to be the distance here. So that's going to be that's too thin. Inner radius. There we go. All right, so this inner radius, and then we also want the outer radius, right? And the outer radius is just going to be this radius right here, right? So this is our outer radius. Wow, my handwriting is great. All right, inner radius, outer radius, and then we want a detail level for the number of things we have, or number of like divisions we have in this whole mesh, right? Yeah, so we also need a number for that. So we're just gonna call that n, I guess, or something. How do you make n's? There we go. So n for the amount of like detail level. So let's call that detail level. There we go. So you're just gonna draw lines at the wait, ID and OD. What is ID and OD? I'd expect handwriting to improve with HRT. Nope. Turns out that's not how that works. Inner donut, yeah. Also diameter, who would use diameter? We're using radius here. Diameter? Are you the sort of person who would use pi? Jeez. Okay, I think this makes sense, right? Are we ready to do this? Cool. Let's define all these. We have float, inner, radius. We have another float for actually let's do radius, inner, because I like to align my variable names. Outer, And then we have another one for the detail level around this one. That's an integer for the number of divisions, right? So we're going to have an integer, and then this is going to be detail level, or maybe divisions or something. I'm not sure what we should call this. Thank you for the follow, Thea. Let's see, this is kind of the angular segment count, right? Angular segments. All right. I probably want this to be minimum of 3, right? Otherwise it's going to be a degenerate shape and not have any volume. So let's make this a slider. This is going to be a slider from 3 to, I don't know, 256. All right. Cool. Radius. Maybe we want this to be, excuse me, a slider too. So from tiny 1 centimeter to 1 meter, maybe. It's probably great. Outer radius maxed out at 2 meter. Actually, let's do a radius inner and a thickness instead. Because if we have an outer radius, we could like make it under, I don't know, like put it under the inner radius and whatnot, which would be weird. So let's not do that. All right. Not capping at 360. Why would I have 360? Like 1 division per degree, isn't that kind of strange? I don't know. I reject 360 as a significant number. Okay. Let's make an empty game object. We should probably remove the old stuff to clean it up a bit. I don't need the quad generator anymore. 361. Okay, there we go. For 20, obviously. That would be very appropriate for the stream. Heck, I need to drink more water. God damn it. Why do they call it Xbox 360? Because when you see it, you turn 360 degrees and walk away. Wait, 360 would be the same. You would walk towards the Xbox for a short while, and then you would walk away from it. So technically, after a while, it makes sense, but depends on the gimbal locking. Sure. It's like, oh, god damn it, my Euler angles are completely messed up today. I cannot walk properly. Cool. Okay, so we no longer have the outer radius. Now we have a thickness value. So that's just going to be this distance right here, right? Thickness. That was a very bold font that I was using for this, appropriately enough for the thickness word. Thank you for the follow. All right. Cool. Also, thank you for the follow, Old Black Train. Alright, are we good? We've got some variables now. I guess we should also expose these to the inspector so we can actually see things. There we go, and let's assign it to this object. That was a quad ring. There we go. Nice. Let's set up some default values. 0.5 is probably good. 0.25. Okay, I usually like to do things very step by step when I do stuff like this. So usually I start by like visualizing all of these things, right? So I quite often use the onDrawGizmos function in Unity. So I'm just gonna draw the inner radius and the outer radius. So I'm also gonna make a property out of this. So I'm gonna make a float property called outer or radius outer. And that one is simply going to be radius inner plus thickness, right? Because we might want this value for something. Right, so now we got radius outer. So let's draw those two. Let's visualize those two. Also, I might also want to do when this one is selected and not just every time. Okay, let's draw this. So that would be gizmos dot draw. Do they have draw circle yet? No, okay. I usually have to write my own draw circle, but let's do draw wire sphere. All right, and then we simply have the position, which would be the origin of this object in world space, and then the radius inner, and then we draw radius outer too. There we go. What does the equals greater than operator do? This is a kind of like an inline assignment that you can do. So this is equivalent to this. So I think it's called expression embodied member, where you kind of make a shortcut where instead of doing all of this boilerplate, you can just, do this, and then you got the same code, right? Yeah. So it's just a shortcut for kind of like making these a bit more simple. Another thing you can do is to do that for functions as well. Like if you have a function, something like this, you can also make that like, you don't even need the return value like that. So you can also do that for functions. Oh wait, it has a return. There we go. Yeah. Can you color gizmo spheres? Yeah, you can. There's gizmos.color, and if you set that one, everything you draw after that one is going to be colored by that. Yeah. It's also used for lambdas in C#. Yeah, that's true. Anyway, we just need this for the outer radius of this one up here. So there we go. Starting to use a lambda for everything. It's nice. I like it. It's a very useful operator. Right. So we are drawing these two wire spheres. Let's see what that looks like in Unity. Recompiling. There we go. Also, this is messy because I don't want to draw spheres, but... Okay, should I make a draw wire circle function? Because this is messy. It's kind of not what we're supposed to do in this, but sounds fun. All right. Okay. Let's do it then. Public, static, void, draw, wire, circle. I think I'm just gonna, yeah, let's give it a position and an orientation. There we go. What's the Freya Gizmo extension package hitting the Unity store? I actually have a surprising amount of Gizmo drawing functions like across all the projects I worked on. I have so many of these for like at the end of the production of budget cuts, I had like a bundle of like, I don't know how long that script was, of like gizmos and handles and stuff for drawing a bunch of things in Unity. But yeah, anyway, all right, draw wire circle, we want a position, an orientation, and we need a radius, right? And then we might want a detail level, but let's default that one to something. Okay. All right, so we're gonna have to do some math now. So we're gonna have to use the sine and cosine in order to get like a vector that is pointing at a specific angle, right? Okay, so we need to do this for, let's see, first we need to define a bunch of points, right, in 3D space. Actually, we might want to define the 2D points first. So points equals new vector2 array, and then the amount of points in this one, I guess, is just going to be the same number as in detail. And then we need to iterate through all of these, each and every vertex, right? Okay, so how do we do this? Well, we need to first have the correct number of iterations, and then we need to convert all of this to an angle, right? Yeah, exactly. Like Strophium is saying, sine gives you y value and cosine gives you x value. So it's kind of like if you imagine a coordinate system like this. All right, and then you give this one an angle, for instance. Let's switch color. So you say you want this direction right here, like as a vector, right? Then if you want the coordinate for that one, you can use the cosine to get the cosine of the angle, this angle right here. If you use the cosine of that angle, that gives you this distance on the x-axis right here, right? If you use the if you use the sine of the angle, then you get the kind of the vertical distance right here, right? Hope that makes sense. So basically we need the angle. That's what we need to do to get all of these points around the circle. So the goal is that we're going to have points like this, right? That goes around the whole unit circle. Did that make sense? Okay, so first off, we need an angle, right? And we want that in radians, I think. Sine of angle f. It doesn't say in Unity what, if it's radians or degrees. I think it's radians, but let's look it up because this has to be correct. In radians, perfect. Wacko Joe, thank you for the follow. Right, so this is going to be only our 2D points, right? So let's call it points 2D. So this is kind of just going to lie within the unit circle, right? Okay, now we need to get the angle. So how do we do that? Well, we need to first convert the index of the detail into a percentage around the whole thing, right? So usually I call that the t-value. So I'm gonna do that by doing the current index divided by detail. And one thing that you need to be careful with here is that usually you have two integers that you're dividing with each other. So you're probably gonna want to convert one of these to a float to make sure that it's a float division. All right, and this should give us the t-value as in a percentage going from 0 and then all the way to 1 as you reach the end. One thing to note here is that this one is not going to return to the original position. It's gonna, this one is going to stop right before the end, which is what we want in this case, right? Okay, so now we need to convert this to an angle. How do we do that? Well, we need a circle constant for that, and that is, there we go. And there we go. We're going to use tau, and that's 6 point whatever. There we go. So this is a full turn in radians. So if we measure things in radians, then this is the amount that is one full turn around the whole thing, right? So we're going to simply do t multiplied by tau gives us the angle in radians. All right. And yeah, tau is 2 pi, but you don't need to learn about pi. Never mind that. Okay, so we got the angle. Now we just need to convert an angle to a 2D vector, right? So then we do that by defining a vector 2. Vec equals new vector 2. And then for the x-coordinate, as we mentioned earlier, that would be the cosine. So that's the cosine of the angle in radians. And then we do the same thing, but apparently I pressed the wrong keys again. There we go. Then you do the sine of the angle to get the y-coordinate for this vector, right? Okay. So that gives us the vector, and I want to assign this to one of these points. So we can just like straight up go to Chrome, apparently. There we go. So now we assign that to that point right there. Okay. All right, so now we have a bunch of 2D points. We don't have these in 3D. These are just 2D points on the unit circle, right? But we want these to be drawn in 3D, which is not what we got yet. So let's get the, let's do the 3D point array. Points 3D equals new vector 3 array. All right, so how do we define the 3D points? Well, actually we could make the 3D point array immediately if we want to. Trying to think of pros and cons. Actually, let's just do it immediately. We're not going to visualize the step between regardless. Yeah, let's go back to having like the 2D point defined here. So points 2D in this case is just going to be on the unit circle, right? So now we need to transform this one to whatever, position in space you wanted to draw this in, right? So first off, we need to transform this based on the orientation and whatnot, right? So we can simply do that by taking the quaternion that we got here. And then we take this point and transform it by the quaternion. So if you do that, you can get the 3D point. 3D equals the quaternion, and then you multiply that by 2D. Might be the other way around. No, this seems fine. Okay. So basically, you can think of the quaternion as a gizmo, right? It has, a direction pointing to the right, direction that's pointing upwards, and a direction that's pointing forwards, right? If you multiply a vector by quaternion, you transform it into the space of the quaternion. So if you have a vector that is simply pointing straight upwards, then it's going to point in the up direction of the quaternion that you multiplied it by. Yeah. So this is going to give us it's going to do a vector transformation to the orientation of the quaternion you've got here. But it's not going to have the offset of the position we want to draw it in, right? And this one is also not scaled by the radius. So we also want to multiply this by the radius. If we want to be slightly faster, we might want to do that with 2D instead of the 3D point. So let's do that. There we go. So now we scale this one by the radius. Actually, we might as well do that in here. That's probably even faster. All right. And then we're done with the vector transformation here, but we also need the origin of this one. So let's add the position to that. And I think that should be it to get the 3D points. So let's assign that. There we go. Alright, so before we do the lines, let's just debug these as spheres. So we can simply do another iteration. So we iterate through the whole thing. For each point, we're just going to do a little gizmo sphere, right? So we're going to do gizmos dot draw sphere, and we're going to draw it at the location of the 3D point with a tiny radius. There we go. All right, so now this one should draw a tiny little sphere for every point along this circle. So let's see if that works. I'm lost by multiplying a vector 2D by quaternion will convert it to a vector 3. So it will basically cast the point 2D into a 3D vector. So it's very similar to doing vector 3 like this. And then it gets transformed to the space of the orientation we have in the quaternion, right? So this is equivalent. Yeah. So it just inserts 0 for the z component of the 2D point, right? Yeah. Hope that made sense. All right, so draw all points as tiny little dots. There we go. All right, so let's call this function to make sure that it works. Let's skip the old ones. Draw a wide circle. Transform dot position. Transform dot rotation. Radius, we can set that to 1. Detail, we can go for default. What's the name of the previous song? I don't know. Previous song, I don't know. That's, wait, I can check the history. Previous song was Nord by, that seems Swedish, Kafatorsk. Yeah, Kafatorsk, if you want to pronounce it in English. Yeah. Alright, so let's see if this works. There we go. Look at all of these dots. That is working very well. So we can rotate this one now. You can see that the orientation of it like follows proper. Yeah. So we're making progress. All right. This is actually what dots is for... Yeah. This is what they're working on at Unity for the dots. Okay. Now we don't want to draw these points. We want to draw a circle, right? That was the whole goal of this. Then we simply iterate through the entire array, and then we draw to the next point, right? So from the point I to I plus 1. So we're gonna do, let's see, handles. No, wait, actually, if we want this to have anti-aliasing, no, we're gonna do gizmos. There's like a slight difference between gizmos and handles, but anyway. Oh, did I name the next song? Right, heck, I forgot, sorry. Previous song was Midnight by Todge. Handles only works in the editor as well. Yeah, I'm pretty sure. But we're only doing editor stuff right now anyway, so. All right, draw line. We're gonna draw a line from point A to point B, and then we're iterating through each thing, right? So what's gonna happen is that we, for each of these points, we're gonna say, all right, draw a line from this to this. Next iteration, we draw a line from this to this and so forth, right? So let's do detail -1. I'm gonna skip the last one. So we're gonna draw a line from points 3D 0, no, I, and then to points 3D I plus 1. What does handles refer to? OpenGL handles? No, that's Unity's handles. Usually use a handles class to make interactable handles for gizmos and whatnot. But yeah. So generally that's for interactive UI elements within the scene view. Right, so now we draw a line between those two, and then we need to finally draw a line between the last point. So that would be, what do we call it? Detail. So we need to draw a line from the last point, which is detail -1 to 0. There are other ways of doing this. Like I could do the full iteration, but then I would need to modulo this one by the detail. And I presume it's faster to not do a modulo for every iteration. Or maybe that's optimized by the compiler, I don't know. But yeah. Or wait, modulo would be inside of the index, yeah. Because we don't want this to overshoot, right? But we need to draw one more line than the, yeah, we need to go one more step, right? Anyway, I think this is faster. Let's see if that works. Recompiling. There we go. We can now draw circles. I think it's optimized by the compiler. Well, we could actually ask a compiler dev who's sitting right next to me if she's got time. Do you have time? Do you want to come on stream and talk about basically, so we're trying to figure out, you know, so right now I'm drawing a circle and I want to connect a bunch of dots with lines, right? So I'm iterating through every point along the circle. So right now I'm skipping the last one because I need to go from the last index to 0, right? Yep. And quite a common way to do that is just do the modulo of the full length, right?
Yep.
So what we're basically wondering, would the compiler optimize out the modulo, or would it actually run the modulo every time?
It would run the modulo. How would it optimize it out?
Because it would presumably know that the first, almost every single one is not going to have to do the modulo.
Right. So that would involve the loop being unrolled, which happens in like very high performance, like shader code might do this.
Right.
C# does not.
Okay.
However,
I think it might be a bit low on the mic, by the way. But
however, there might be some other performance issues with like calling the function multiple times in multiple places. Like if you're worried about the performance of a modulo, you're going to be worried about a lot of other things too.
Probably, yeah. Yeah. Yeah, all right. Neat.
Yeah, if it knows how to unwind the for loop, then yeah, then it can. But that's for like very optimized languages, not C#. Yeah.
Yeah, right. Cool. Thanks. So then the first one should be faster, right? Not doing the modulo.
It's Debatable.
Tiny bit faster. It's faster to an insignificant amount,
No,
probably.
there's other things that makes that slower.
Okay.
But yeah, it's very insignificant either way.
All right. Okay. All right, so let's see. We've now got all the lines. It looks like a circle. I think everything's working. Neat. So let's use that one in its proper context, which was we want to draw the inner radius and the outer radius, right? So we're gonna do radius inner, comma, detail. We might want to do that too, actually. So radius outer, and then we pass the angular segments as the amount of segments in the gizmo. So, because then we're actually going to visualize the exact shape that this is going to have. So that's also pretty useful. All right. That looks good. So if we increase the angular segments now, you can see that we get more and more segments on this. Also, our maximum is extremely high. Let's go for like, maybe 32 is too much even. The slider, like in 1 pixel, went from like 3 to incredibly high, but all right, that's looking good so far. So now we need to generate a mesh in all of these, which is incidentally very similar to what we just did, because we need all of these vertices, right? So maybe we can actually simplify this a little bit. Let's see. We can make a few functions out of these. 3 segments is my favorite type of circle. It's a very good circle. I like it. Oh yeah, we didn't test the inner radius and whatnot. So this is inner radius, and then we have thickness. Perfect. All right, so there are a few things that we're going to want to do in both of these code paths, right? So, for instance, we want to get the 2D vector by an angle with both of these. So let's make a function for that. So public static vector 2 get vector by angle, and then float angle in radians. And then in there, we return this whole thing, right? So return new vector 2. We don't have a radius in this one, so let's just remove that. All right. So now we can do get vector by angle. So we pass in, I guess this is technically unit vector. Maybe I should clarify that. All right, then we pass the angle into that one, and then we got our point 2D. All right. Good. Why is this sad? Does not exist because I renamed it. All right, good. Now, we got that down, so let's start defining our vertices. So generally, this can get messy very quickly unless you keep track of exactly what number means what and how all of your vertices are set up, right? So one thing that's very, very crucial for us is that we need to remember exactly if we specify the rings first, or if we specify if we do them alternating. So for instance, it's important to know if we index the vertices by 0, 1, 2, and so forth all the way around until we get to here or here, in which case we switch to the inner ring. So then this is going to be 8, 9, 10, and so forth, right? If we're doing that, or if we're doing 0, 1, 2, 3, 4, 5, and so on. I think in this case, I think it would be easiest to go for the alternating one, because we do need to define triangles alternating between all of these, right? So I think in this case, we're going to go for the alternating version. So first off, we need to define the we need to be able to iterate through all of these and then assign all of these vertices or save them in a list, right? So okay, so what's the total amount of vertices that we're gonna get in this one? The total amount, assuming there's no seam in this location right here, that's going to be detail level times 2, because we have 2 rings, right? The outer one and the inner one. If we have a detail level of 3, then we're going to have, you know, 1 outer triangle like this, that's 3 vertices, and 1 inner triangle like this, and that's 6 vertices in total. So detail level times 3 would be our total vertex count. So let's make another property for that. So float vertex count would simply be radius. No, detail, we call that angular segments, right? Angular segments times 2. There we go. Should probably move all the properties down there. I'm low-key hoping for a code mistake so it generates really crazy mesh. It's probably gonna happen. It happens a lot. Mistakes are being made all the time when generating procedural meshes, so... heck, I also need to drink. Hold on. Yeah, I'm really bad at remembering to drink water. I'll be right back. Look at that cat. That's it.
He's been a grumpy cat.
He looks good now, though. What kind of telescope do you have? That is not my telescope. It is Ashley's telescope, or Kyperia in chat. I don't know what brand it is. You'd have to ask her. But yeah, she's in chat. You can probably just ask. Okay. So far we're making sense, right? Do you think, is there anything that you think I've been unclear with, or things that are confusing? Also, maybe we should move like some of these things to a separate class, because some of these like are not really related to this. Let's do that. Let's do things in a clean way. Let's make our own gizmo script. Cool stream, by the way. I had to generate grass quads a few months ago. Had so many issues, but eventually figured it out. This is going to be educated for me. Awesome. I'm glad. Okay. We have a gizmos class. I'm just going to move the gizmo thing into this one. So using entity editor. Oh, we don't need editor for gizmos, actually. Never mind. There we go. Alright, let's just lift this function out of this code and move it into the gizmos script. Alright, then I also want another script for math functions. This is why we need static extension methods. Where are my static extension methods? Alright, we got a maths class now. So we're gonna fill this one with some math. So we made 2 things that are useful. So we have the tau constant, and then we have the get unit vector by angle. So I'm just gonna move both of those into the maths class. Alright. So now we can access that one through maths. And this one through gizmos. Sorry, gizmos. I have this naming convention of like whenever I want to extend like some math related thing or gizmos, I just add fs to the end because I add the s to the end of math, like Unity's math function or whatever, but it looks silly, but I like it. Gizmos for fuck's sake, yeah. It's only one F though, so it's more like gizmos fuck's sake or forsake. Okay. I think we did a proper cleanup. What's our main script looking like now? Good, now it's not full of garbage. Cool. We got that one set up now, so now we're ready to do the whole iteration throughout the whole circle and do the whole thing. So depending on if you want to do this dynamically or not, you tend to want to split things up in different ways. I think in this case, to make things a bit easier, I'm not going to do a proper editor script for this. This is probably just going to be a, you press play and then you can tweak it afterwards. I think that's what I'm going to do. All right. So let's make an awake function where we want to, generate the mesh, and a function called generate mesh. So in generate mesh, we're going to do everything that creates the mesh data and assign it to the mesh and all of that. But in awake, we're going to make sure that the mesh exists in the first place. So this is where we're going to have, create the mesh and then assign it to the mesh filter and whatnot, right? So this script is going to presume that we need that we have a mesh filter. So maybe I should do like the require component thing. So type of mesh filter. There we go. So attaching this script to an object right now would also automatically create a mesh filter. And trying to delete the mesh filter, or trying to delete the mesh filter while the script is attached would give you a warning if you have this attribute on your model behavior script, right? So that's pretty useful sometimes, or frustrating. It's usually both. All right. So now we can assume that there's a mesh filter in this one. I should probably also actually add it to the object, and then also a mesh renderer. So let's give it the. Should we use the mango material? No, because we're not going to generate UVs for a while. So let's go for default material. All right. Why is this one sad? Because I didn't recompile. Okay, so now we have a mesh filter and a mesh renderer on this component, so now we can actually assign to it. Going back to our quadring, now we can assume that the mesh filter is there, right? Because we basically guaranteed it with all of these attributes and whatnot, right? So let's assign it. We can do get component, mesh filter, and then we do dot mesh or shared mesh and then set that to the mesh, right? And then we need to generate the mesh. We probably want a reference to the mesh, so let's make a non-serialized field for that. So we're just going to do mesh. All right, so mesh equals new mesh. There we go, and then we should probably give it a name. So this is going to be the quad. What do we call it? Quadring. There we go. So we create the mesh object so that we have something that we can, modify, add triangles to, and all of that, right? And then we assign it to the shared mesh. And then if we modify the mesh after this point, it's still going to be, updated on the mesh filter too, because this is a reference to the mesh. It's not a copy of the mesh that we assign here. So we can just modify the mesh however we want after this point, and it's still going to be updated in the mesh filter and properly and whatnot. Yeah. All right. I hope that makes sense. Right, so then we can generate the mesh. We're going to do that every single frame because we don't care. We're just going to go for it. I'm also going to use an expression body for this because that looks cool. Okay. So we're gonna call generate mesh every single frame. So let's see how we would set this up. So first off, in case the mesh already has data in it, we're gonna have to clear it. So we're gonna do mesh.clear. Otherwise, when we assign, like, if the vertex count changed, but we still have the triangle indices from the last mesh, and then we try to assign the vertices, we would get a warning because there's a mismatch between vertices and triangles. So calling mesh.clear will ensure that the mesh doesn't have any data, and it's just pending and waiting for your triangles and your vertices to be assigned to it, right? Yeah. So that's pretty important. All right, so what are we going to do next? So next up, we're going to have to define all of these vertices and whatnot, right? Let's see, how do we do the wire circle? I wonder, we can probably hijack some of this code right here. Although actually, this is going to be easier because we don't need to apply the transformation because we're going to do all of this in local space. So, okay, good. This is going to be pretty straightforward then. So let's first iterate through all the vertices, right? So let's grab the vertex counts. We also need, wait, why is this? Oh, because that's keyboard. Why are you in the wrong mode? This should be an integer. So, all right. Now we need to first generate the vertices, right? So list vector 3 vertices. Think about the follows, Iphonic. What would happen if you set only the vertices and keep the triangles to the mesh? So if you only set the vertices and keep the triangles, the triangles are still going to be attached to whatever index they had before. So, you know, if a triangle says connect vertex 0, 1, and 2, and then you modify the vertices, the triangle is just going to move to wherever you move the vertices, right? So, yeah. I mean, it's only going to give you an error if there's a mismatch between the, you know, either triangles. Yeah, if there are triangles referring to vertices that don't exist, or rather vertex indices that don't exist, you're going to get an error if that's outside the array, right? Yeah. Okay, we're going to generate the vertices. So let's just make a new list vector 3. We're not going to care about like generating garbage and whatnot in this right now. We're just going to naively write this code until it works, and then we can optimize it later if we want to. Okay, first off, we need to generate the vertices. And again, now we need to iterate through this whole ring, right? And we can simply just iterate through the detail level, right? And then we can generate 2 vertices at a time. So the for loop is going to go through this one because that's iteration 0. Then iteration 1 is going to go through here. Iteration 2 is going to go through here, and so forth, right? So this is how we're gonna assign all of the vertices. So we're gonna do outer ring first and then inner ring. Okay. So let's do that for loop. So this one is going to iterate through the angular segments. I should probably change this to angular segment count. And there we go. So now we iterate through each of these angular segments, right? Think about the follow, Cedric. All right, so how do we get these points? Well, we're probably going to want to define these in 2D. Now it's going to be relative to this coordinate space. We don't have to do the 3D transformation or anything because again, all the data you pass to a mesh is going to be in the local space of the mesh itself, right? You know, model space or local space, whatever you want to call it. So this is probably going to get pretty straightforward. So first off, we need the angle, right? So let's get the angle. So that's going to be the same thing as we did last time here with the get unit vector by angle. But then we're also going to have to get the t value right here. Yeah, I think we can just copy these 3 lines because they're going to be equivalent in the quadring. There we go. So detail is now going to be angular segment count instead. So now we have the angle, and then we get a 2D coordinate based on that angle. Let's make z equal cosine of x. We can experiment with this if you want to. I just want to make the proper thing first, and then we can start messing around with it. All right, so now we got the 2D point, and let's see, this one is still this is a unit vector still, which actually reminds me that this one isn't scaled by the radius, so I need to do that here, because previously that was baked into this function. But that should be correct now. All right. Okay, so this is rather the direction. So let's call it the, yeah, direction. We can just call it the direction. That's actually perfect. So that's the, what we got now is a vector that is pointing in the direction that these 2 points are going to lie, right? So for this iteration, we're going to get a vector that points in that direction, and then we're going to get that vector all the way around this, right? But we need to have points at a specific distance, right? So what we can do is we take that vector, multiply it by the distance out to the vertex position, right? Think about the follow. Okay, so again, we need to generate 2 points out of this. First the outer one, then the inner one. Then we go to the next iteration, generate the outer one, generate the inner one, and so forth. Yeah, so we can simply do vertices.add, then we add the outer one first. Thank you for the follow, Macabre Art Games. So we add the outer one, which is going to be the direction multiplied by the radius outer. There we go. And are you okay?
Yeah, I was thinking about what to eat.
Oh, gotcha. Okay, so we got the outer radius, and then we need to add the inner radius 0.2. Okay, so now we just added this vertex and then this vertex. So that should be it for defining all of the vertices, I'm pretty sure. So this one is now going to iterate through each of these segments separately, and it's going to add all of these points one after another. And then it's finally going to stop at this one right here. All right. Did that make sense so far? Is there anything that's unclear that you feel like I should clarify? This is very similar to the ring that we generated before. Also, I would also, every time you do procedural meshes like this, I would always make sketches like this. It's so helpful to remember, you know, the way you set up the vertex indices and whatnot. Because once you get to the triangle step of, you know, having to specify how triangles are connected to vertices, that's going to get super complicated unless you have a visual map of that, either on paper or in your head, right? Yeah. Okay, so now we have generated all the vertices, and now we just need to get the triangles, or just get the triangles. Triangles can be, they're often like the most complicated part. Okay, so let's see. Angular segment count -1. No, we don't want to do that here. No, this makes sense. If you do -1, that's only if you want to have one more iteration that is the same direction as the first one, right? But we're not going to do that now. So, okay, now we need the triangles, right? So triangle indices. Right, we're not going to explicitly define those. We're going to generate those. Cool. So let's see. Let's undo these boxes. We don't need those. And now we need to think of how do we want to define triangles, and do we want to do 2 at a time or what? I think we are going to do 2 at a time. I think that's the most straightforward way of doing this. So again, we're going to do 1 iteration per angular segment. So the first iteration is going to generate all of these triangles. So this is going to be iteration number 1, where we're kind of, you know, we're starting out on this one, and then we have this as kind of our origin, where we define, you know, how all of these triangles are connected to these vertices, right? On the next iteration, we would have like this as our roots, and then we calculate, you know, what the indices for the other ones would be, right? And so forth. And then we iterate through like that. This one is going to have some modulo to make sure that these 2 vertices, when we get to this point, that this one has to loop around to 0. But yeah. Okay, so let's iterate again. We're going to go through each angular segment. And then we're going to add let's see, first we're going to have a root index. So I usually have a root index because that makes things easier to conceptualize. So the root index is going to be the one that's up here. And in the next iteration, it's going to be this one. In the next iteration, it's going to be this one, and so forth. So everything's going to be relative to the root index in the way that I usually like to define these. Okay, so in this case, we're going to have a integer for the roots index. And that's going to be, if we look at this one, we can see that the angular segment that we're currently on times 2 gives us the root index, right? Because this is going to be 0, this is going to be 1, taking 1 times 2 gives us 2, this is going to be 2, doing 2 times 2 is going to be 4, and so forth, right? So root index is simply going to be I times 2. Which makes sense, because we have 2 points per iteration, right? Or per vertex iteration that we did before. So yeah. So that gives us the root index, and then we need the then we need to define the what is the index of the next triangle, right? So let's see. If we want to do the inner vertex from the root, we add 1, right? 2 plus 1 gives us 3, and therefore we have moved to the inner ring, right? So we can make an index for that one. So this is going to be index inner root. So that's going to be root index plus 1. And then we need this point right here. So that is going to be index outer next. Outer next. And that is going to be plus 1 again on that one. So we can just do root index plus 2. Because adding 2 to this gives us a next one in the outer ring, right? So adding 2 to this one gives us the next over there, and so forth. Thank you for the follow. Alright, so we have the index inner root. That is this one. We have index outer next, which is this one. And then we need finally this point right here, right? Now I'm going thinking, if to do this, you need to sketch geometry anyway. Isn't it easier to just model it? Probably when it gets to more complex stuff, you need a lot of... the way modeling's not a way anymore. I'm not sure how modeling would help in any way. Like, even if I model, the thing that is significant is that I need to remember how I define the indices, right? But if you want to do that through a model, then sure, if that's like faster for you. All right, then we need index inner next, right? And that's going to be plus 3. So now we have all of the indices we need to define the quad, right, for this triangle. So what we need to do is simply add these integers, right? So the first triangle, we're going to add, so let's see, again, we're going to have to do, we go clockwise in this case, if we want the normal to point towards the camera. So the first one is going to be 0 to 3 in this case, which in our case would be root index, and then the next outer and next inner, right? So we add root index, and then index outer next, and then index inner next. There we go. Hello there. All right. Then the next one is going to be, we're going to start with the same one, root index, and then next inner, and then root inner, right? Start with root index, and then index inner next is going to be the next point there. So that gives us from this one to this one, and then root inner, right? So root, index inner root. There we go. Should probably rename this one to index roots to follow the same naming convention. All right, so now these should now define the triangles for those two quads, or for that quad, right? Okay, there's one more thing that is going to break with this. So when we get to the final iteration here, it's going to look for the next index here, but that's going to be a number that's outside of the array. So we need to make sure that that value gets clamped, right? So we need to make sure that that's clamped by the total vertex count, right? So we do have that here. It's the v count variable. So we can, or not clamp, but we need to repeat it, right? So we can do modulo of vertex count for any of these that go to the next, right? The inner one is going to be fine, but the next ones are going to step over the limit. So that's where we need to do the modulo. There we go. Otherwise, we would get index out of range issues. And index out of range issues are just going to be, that's going to be a mess. It happens every time you do procedural meshes, pretty much. Can you explain what modulo is doing there? Yeah, sure. So, what we need is that we have this whole array, right, of each vertex. And then we have, 0, 2, 4, 6, 8, 10, 12, 14, and then we have the last one is going to be this one, which is at index 15, right? So we have these two vertices. We have vertex 14, vertex 15, right? And what we then need is we need to figure out what is the next index here. If we do this naively, this one would presume that the next one would be 16, because the rule that we defined was, take the root index, add a 2, and that gives us the next, index. But it's not going to work in this case. In this case, it's going to go above the maximum amount of elements we have in this array of vertices, right? So what we need to do is to make sure that if it's above 14, or if it's above 15, we need to subtract the length of the array. It's kind of like, you can think of it as a repeating pattern, right? Where if you have an array of elements, let's say we have 3 elements, and you want to go to the next element every time. Actually, let's do 4 elements. So let's say you want to go to the next element, you can just do, the current index plus 1 gives you the next element over. So here you got 0, 1, 2, and 3, right? And what I wanted to do was that I wanted to connect each of these with a triangle. So I say the I and then I plus 1, and then I connect those with a triangle in this case. So then I connected these two. But since this one is a circle, once I get to the final point here, I want to connect this 3 to the 0 here. So I want this one to refer to this one. But if I just naively do plus 1, then it's going to refer to an index here that doesn't exist. So I'm going to get index out of range, right? So what the modulo operator does is that it takes the maximum length of this one, and then it kind of repeats the pattern depending on where you cut it off. So if I say, for instance, if I say 4 modulo 4, that's going to give me 0, because the index 4, or the index 4 here, doesn't exist in the array. But if I specify it with a modulo, it's going to cut it off to 0. If I do index 5 modulo 4, this one is going to give me the value of 1. So it's kind of like if I take this one and I jump 2 steps ahead, I'm going to basically skip immediately here and jump 2 steps ahead. So it's kind of like, yeah, I hope that makes sense. So it's kind of like a way to repeat your index. So if you overshoot the index, it's just going to jump back to the start. Yeah. All right. What did I mess up my drawing? No, I didn't. Okay. Okay. Cool. So we now have our vertices, we have our triangle indices, and I think we're now good to go to assign this to the mesh. Hopefully we are. Something's probably going to be broken. Things are usually broken. All right. Mesh dot set vertices. We're gonna assign our vertices right here, and then we do the same for the triangles. We did not define normals now, though. Maybe we should define the normals. Thank you for the follow, surrounded. Or wait, surround. Okay. Oh. Set triangles. Triangle indices. There we go. Does that one not appreciate? Oh, submesh index. There we go. You can have multiple submeshes in a mesh. You know, in Unity, when you can assign multiple materials to a single mesh, those materials are assigned to separate submeshes. So the way submeshes are defined in Unity is that you have separate segments of triangles or groups of triangles, right? But yeah. You can also have multiple UVs, which isn't confusing at all. Yeah, you can have that, but that gets messy, right? Heck, Steph, thank you so much for the host. You're throwing people straight into procedural mesh generation. Hope that's going to be entertaining for y'all. Also, hello everyone. Thank you so much for the host, Steph. All right. Let's see. Where were we? Hello, Mathemagics. Right, we assign the vertices and the triangles, and in this case, we can probably recalculate the normals as well in case we don't want to like do that manually, right? So we're doing that. And heck, thank you so much for the sub, Steph. That's super kind of you. Also, wow, you've been subbed for a long time. I didn't know that. Heck, thank you so much. All right, so we recalculate normals. We haven't done that manually, so we're just gonna do that. And I think that's it. So I think we now are gonna generate a mesh out of this. Let's see. We are doing procedural mesh geometry. All right. Let's see, we're running this every frame. Right, so we can actually modify the parameters. Let's see just how broken this is gonna be when we hit play. That works. I think we did it. That's a mesh. All right, let's see if we can modify these. So if I modify those, we're gonna get a quad strip. And then, yeah. No idea what's going on, just know there's a super cutie doing it. Heck. All right, so now we got this mesh, and we can change the inner radius, we can change the thickness of this one, and everything's gonna work the way we expect it to. Yeah, so that's our procedural mesh generation. All right, is there anything we want to do with this? So let's see, do we want to generate UVs? Do we want to generate normals? Normals is going to be pretty straightforward. Yeah, normals were not assigned manually this time. So this time I just did recalculate normals. So that's kind of automatically done by Unity. So if we want this one to be a bit more efficient, we can do our own normals, which... Heck. Hello, Thart.
He is not happy.
Why are you unhappy, Thart? This is quality content. This is full screen.
I think he farted.
That's not going to go through stream at least,
Yeah.
so that's fine.
It was big boy.
Could I make a GitHub gist from this code when it will be finished and shared in the chat? I'm probably gonna do. I'm probably gonna make the code available for patrons because I have a Patreon and I feel like I should have more incentives to be on my Patreon. So I'm gonna make all of this code available for patrons. So yeah, for those of you who are there, you can just like take this code and then copy it and paste it wherever you want it. Yeah. Heck. Right. Also, thank you so much for all the follows. Heck, so many people. All right. Oh yeah, heck, I forgot to link my Patreon. I don't like advertising my Patreon. I always feel shitty asking for money, but just anyway. All right. Also, my posture has been garbage this whole time. I think my head was like down here when it really shouldn't be. Right. So let's see, we have our triangle indices and all of this was assigned where we're going to do normals, right? So if we want to do normals manually, we can simply make a normals array out of this one. So now we have the normals and then we can assign them just the same way we assign the vertices and they're all going to have the same normal, right? So if we go to the mesh, we want the normals to point to the z-axis, right? Which is kind of the default normal. So we're going to do normals.add, and then we're just going to add vector3.forward, which is equivalent to, you know, new vector 3001. So vector3.forward is just an alias for that. You never did the you must be this tall to code? No, I didn't do that. Heck. Water. Good idea. I'll do that after the normals. Okay, we need to add 2 of these now because we have 2 vertices, right? We're adding 2 vertices for each. So yeah, so we're now adding the normals. And now we don't recalculate them manually anymore. So now we need to do set normals, and then we send the normals to this one. So that's going to be normals. And there we go. So now everything should be Gucci and faster and better. Love your voice. Thank you. All right, so now we assign the normals manually. Hopefully that works. I guess maybe we should verify that before I get too happy. So let's turn off the directional light and create a point light. That looks correct. If you look at the correct normals on this one. All right, what do we do next? Do we want to do... Okay, there are... you already generated a mesh never frame, maybe do some animation with it. Could do that. That gets complicated though, in case we want it to be... like it gets complicated if we want that one to have correct normals too. But we could do that too, if you want to. That's where like recalculate normal is useful. Like if we do recalculate normals on something we're deforming in real time, that's going to automatically have quote unquote correct normals depending on how we set it up. So yeah, but yeah, it's going to be more expensive. So it's much faster to calculate that on your end. But yeah. But I mean, we could do a bunch of things. Like say when we generate the vertices here, for instance, let's say we offset the inner one by vector 3.forward, for instance. Let's see, is this a vector 2 array? Wait, I'm confused. Oh, right, because this one has to be cast to vector 3. There we go. So if we do something like this, now we've like offset the inner ring, for instance, by a very large amount. Probably should increase the radius for this and thickness. So now we have this like tapered thing where we can also increase the angular segments and whatnot. So yeah, we can just like, depending on how we want to do all of this, we can, you know, tweak every single part of it individually until it looks the way you want it to, right? Yeah. So in this case, I just added to the inner ring, right? Z equals cosine of x would be potentially fun and normal breaking. What is x in this case? Is that the angle or? We could do that though. This seems fun. Let's do the cosine of the angle times 4, and that's going to be our z offset. Wait, not normals. Heck. There we go. That one's also going to give us a warning because casting is not easy. Right, and that's not a vector, so we need to do vector 3.forward times that. There we go. This should give us a wavy circle. It's probably going to be very wavy. It's incredibly wavy. Look at this one. Probably going to have to make it way bigger. Add more thickness and then more angular segments. And then look at that squiggle. That's a squiggly boy. I'm not entirely sure what we'd use this for. I feel like I want more segments on this, just to look at the smoothness. Hello, cat. Hi, Thor. How can you draw both sides of the mesh? Probably the best way of doing that is to define that in the shader rather than having like two triangles for each triangle, right? But you can have duplicate triangles if you want to, but it's probably easiest to do that in the shader where you tell the shader not to cull the back faces. But yeah, there we go. That's our squiggly mesh. Also, thank you so much for the Prime sub, HypnoPunch. Yeah. All right. Did that make sense so far? Is there anything you want me to go through with this? Like we haven't talked about UVs, for instance. So we haven't really set that up. So for instance, if we want to apply a texture to this, then that's just not going to be possible. Yeah, UVs are not calculated right now at all. So that's just not a thing right now. Do we want to do that? Should I show you how to set that up, or?
No.
What was he doing?
Eating shit off the ground.
Oh, gotcha. If it's not too time consuming for you, it doesn't matter. I'm fine. Like if you want to see UVs, we can do UVs. All right. Heck, there. One cool and really useful thing to do with procedural geometry is to extrude at runtime and strip of vertices. Yeah, that's something I gave a talk at Unite about that a long time ago. On, I think it was called The Coder's Guide to Procedural Geometry. So that was basically that case of extruding something based on a 2D shape to make a road. So it was like a long talk on Bezier curves and procedural meshes and triangles and whatnot. I was considering doing that for this stream too, in case people would be curious. Could I get a jargon buster for UV? Jargon buster? I've never heard of that jargon. Is that... is that just you want to know what UVs are, or? Okay, so let's remove the wave. We don't need the waviness. I guess we could make that a parameter if you want to be fancy about it, but for now, let's just not do that. Okay, so UVs are UVs can be many different things, but the most common use case for UVs is that, say you have a 3D mesh, you know, say you have a so let's see, what in the world did I just do? There we go. Okay, say you have a sphere like this. And then you have a texture, and that's usually, you know, a square picture, right? And then you have this picture, and you want to apply this to an object. But then the question is, how do you wrap this picture around the object, right? Should it just be like a projection, like a projector being lit, like lighting it from above, where it's like, you know, getting stretched at the edges? Or should it be like wrapped around it? You know, how do you apply a 2D shape to something 3D, right? And UV coordinates are usually the answer to that. And so basically UV coordinates are two-dimensional coordinates that correspond to a 3D point, right? So you can see all of these points right here in the 2D view. Those are the UV coordinates for this object. So if I select the UV coordinates at the top, you can see that that's the vertices at the top here, right? So when we map a texture to this one, we're going to get the texture, the pixels that correspond to this vertex is going to be here, and the pixel that corresponds to this vertex is going to be over here, right? And this has a lot of implications. Like, so if I take all of these, for instance, and stretch them, it's going to stretch the entire texture that's mapped to this object. I can show you what that looks like if you want to. So if I, let's see if I take some, god damn it, Windows. So I take a texture. Do I have a texture? Perfect. There we go. We got the perfect texture for this. Let's enable it. There we go. So here, now we mapped a texture onto this object, right? This was a perfect texture for this. All right, so you can see that these are the UV coordinates for this object. And if I want to map this texture in a different way, like I said, if I scale these, things are going to move around in terms of how the texture is mapped. And usually the coordinates repeat themselves as well. So if I move coordinates outside of this one, the texture is going to repeat itself and you get this type of effect, right? Yeah, and then again, if you like move this one, it's going to move how the texture is mapped to the object. Or even if I move individual segments of this one, like I can select the part that's mapped to the eye and just move that out of the way, and I'm going to be able to warp the texture like this, right? So yeah, That is basically what UV coordinates are. Mathematically, what a UV coordinate is simply two values, an x value and a y value for a 2D vector. So you can actually see the numbers here. They're pretty tiny on screen probably, but so this is the y coordinate of 1, and then if you go to that was the incorrect hotkey, and then here you have an x coordinate of 1. So a vertex in this corner would be, x1, y1. A vertex in the center would be 0.5 in both x and y, right? Yeah. All right, did that make sense? Was that a good explanation of UVs? But that's generated by Maya. How would you go about calculating the UVs on your circular procedural mesh? Yeah, so to do that, we need to basically we need to answer the question, how do we want to map the UVs before we can generate the UVs, right? So answering that question is the most important thing. So we can actually do two cases in Maya. So let's say we have this cylinder right here. And then we got the UV coordinates. Probably want these to map onto 0 to 1. So close enough, like that. All right, let's apply the same material again. So that's going to be that one, right? Okay. And then we flatten this one like our case in Unity. Okay, here's one way we can map the UVs, right? So basically, if we map the UVs like this, we kind of like take whatever we map onto this and stretch it around the whole thing, right? So for instance, if I scale the UVs like this, you can see that they're going to start repeating themselves. So, do we want them to be, this looks great. I love this thinking face. Anyway, so yeah, do we want to map stuff like this, or do we want some other type of projection on this? So this is one way of doing it, but a different way of doing it is that maybe we want a top-down projection. So that would be planar mapping on the y-axis. Like this is a different way we can map the UVs, right? So if we zoom in here, you can see that the UVs are now mapped in a top-down projection and onto this texture, right? And this is probably the easiest way to set things up. But then we might want to do something like this, where we have like a repeating pattern along this curve, right? So say you have something like an effect trailing a sword or something, and you have a character that's swinging the sword, and then this mesh is going to be the trail behind the sword, right? In that case, we probably want to have a very simple texture that defines the look of the trail, but then we want to repeat that texture around the whole circle. And that's when this first UV mapping would be pretty useful, right? Yeah. Why do you use Maya, not Blender? Because I'm used to using Maya, and I haven't gotten started using Blender. Yeah, so basically we need to decide first which one of these two projections do we want. I think in my cases, I usually want to do the top one. So say we want to generate something like a road, and this is a curve in that road, then we probably want a road texture that repeats itself, right? I have not checked out New Blender now. All right. Okay, so I feel like we should go for the top one, right? So going back here, the UVs would then be another array, but it would be an array of 2D coordinates, right? So let's make a list of vector 2, call it UVs, new list vector 2. All right. Let's see. So for every angular segment, this is where we add 2 vertices, right? So what we can do now is to figure out, okay, what values do we actually want here for the UVs? If we want it to be completely within the square, as in want to do something like this, right? The x coordinate of this one is going to go from 0 to 1 around the whole circle, right? Because that's what we're visualizing here. So if I, select these 2 vertices here, they're kind of like just at the start of the circular segments, right? And if I move to the right, you can see that they start circling around further to the right. And so that value is going to be from 0 to 1. And we actually already have that one. That one is the t value right here. The t value is increasing from 0 all the way around to actually not 1 in this case, which is an interesting edge case. So the UVs are going to be incorrect for the last final bit, which relates to the thing we were talking about earlier in the stream, where if you have a single coordinate where you need multiple UVs or multiple normals, you're going to have to split that one and make multiple vertices. Yeah, so we're going to see that interesting edge case here now. So that's a good test case for, you know, how you would fix that and so forth. But let's do this naively first. So, okay, so we got our UVs, and then we need to define those here. So we're going to do UVs.add, and the first UV on this one, that is the, let's see, that's the outer ring. Both of these have the same x coordinate, but they have different y coordinates. So the outer one is going to have a y coordinate of 1. So we're going to do new vector 2. X coordinate was t, as we said. That was the percentage around the whole circle. And then the y coordinate is just simply going to be 1. And then for the inner one, we're going to do the, it's going to have a y coordinate of 0, but the x coordinate is going to be the same. And this should be enough to set up a very naive UV coordinate system for this. And then we need to, as usual, we need to assign the UVs here. So we're going to do set UVs, and then channel 0, because you can have multiple UV sets if you want to, but we're just going to assign it to the very first UV set, which is UV 0. Then we're going to do UVs. All right, let's go back to Unity. We should probably set the angular segment count to something bigger and probably larger in general. All right, actually, a few more segments. How many do you want? That's probably great. All right. So right now we don't really have anything that can visualize whether or not we got this right. So let's add the UV debugging material to this and then hit play. And there we go. So what we see now is that the hold on, I need to orient this one. So what we can see now is that the green values go from 0 in the center and then to 1 here. And that's a y coordinate. So this is looking correct. And we could also visualize just the y coordinate if we want to, right? So that would be in the shader. So I'm just going to go to the shader real quick. And then we're only going to output the x coordinate of this one. So going back here, we can see that it goes from 0 and then it goes to 1. But here you can see what happens. So we need 2 sets of vertices for this seam right here. So what that would be, so what's happened now in this one, if we go back to Maya and look at, if we look at this one, we don't have this case right now. The case that we have is that the final vertices here are basically all the way over here. And you can see that then we get this weird like compression and reversal of the image there, right? So if I pan this one, you can see that we have this weird like reversal on the right here, which is not what we want, right? So basically these two vertices on the far right, these two vertices on the far right, we want these to actually be here and not be over here, right? So then we need to split the vertices, and this is where things might get tricky. So going back to our code, that's the shader code. We don't want to look at that right now. You know, actually, we can debug the y coordinate first, just to make sure that that's correct. And yep, that's correct. That one doesn't have the problem with the seam because they have the same values at the seam, so that's not a problem at all. So the y coordinate's working just fine. Perfect. Let's go back to fixing the x coordinate of this. Okay, so as I mentioned, whenever you have multiple sets of data at a single point, you need to split that into multiple vertices, which means that now we're going to jump into the lovely thing in coding that is off by 1 index garbage. Okay, so what does this mean? This means that when we generate the vertices around this whole object, we need to generate one more set over here, right? So how do we do that? Okay, going back here, this is where we generate the vertices, right? We need to go one step further here. So in this case, we add one more to angular segment counts. So this is going to make it, give it one more iteration. It's going to add one more set of vertices and everything, right? And then what we can actually do is that for the triangles, we previously had the thing where we had to wrap the index, but now we don't have to do that anymore. So actually we have less code now, I think, by fixing this. So now we can just remove those, because now we don't need to generate triangles between the last indices and the first one, because now the last indices and the first indices are at the same location. So yeah, this actually, surprisingly, this became easier to read. So let's see if that actually works. This gets more tricky if you use arrays, because then you need to have more manual indexes everywhere. So now you can see that it goes from 0, and then it goes to 1, and then it drops down to 0 again. And that's exactly what we wanted, because the texture is going to repeat itself if we map a texture to this, right? Yeah, so that actually seems to work. And then let's go back to the shader, or not, because I accidentally closed that one. So let's debug both X and Y now, and then go back. So now we have this nice cutoff exactly as we wanted to on the X coordinate around this object. Yeah, so that's how you would generate UVs for that. So it's pretty straightforward. You just need to know how you want to map it, right? And UVs are generally between 0 and 1, and then you just need to think, okay, do I want to map it around the whole thing? Like, do I want the, the angular value to correspond to that or not? Yeah, all right. Any questions so far? Did that make sense? Did it not make sense? Yeah, feel free to ask questions. That is working very well. I'm happy. I need water. Why haven't I had a lot of water yet? It's getting more and more mango shaped. Yep. I wonder why you think it would be easier to project a picture from the top. I think it could be harder to calculate. Probably in this case, yeah. Or no, actually that's, yeah, maybe depending on, it's a minor difference. If you want to do the projection, okay, let's just do the two cases. So radial, no, angular, radial coordinates. All right, let's do the other case then. So we want a top-down projection. So let's comment this out. And so all we need to do here is that we need to, bool property for the editor. We could do that, yeah. Let's do an enum. Project Z. Earlier last vertex was connected to the first one. Now no, it doesn't make a difference. So the problem was that we had to have a seam in the UVs, which means we need to have a duplicate set of vertices there. So yeah, we already had vertices at the same location. Before we had to reuse the old ones, in which case we had to jump to the beginning of that array. But now we don't have to do that jump anymore, which makes things a bit more simpler actually. All right, then we need the UV projection. So UV projection, there we go. Should probably assign a default to angular radial. All right, so now we can branch this. So hacking page up and page down keys. So if UV projection is UV projection angular radial, we do these two. All right, else we do the top-down projection. I guess we should do if there. I guess that you should use a switch. God damn it. I'm grumpy about switch statements. Can you generate things for me? There we go. There we go. Okay. I think I messed this up a bit. All right. Thank you for the follow. It was how to say connected mesh. It's still a connected mesh. It depends on what you mean by connected mesh. There's nothing in like the vertex position is in the same location, so it's still going to be a quote-unquote connected mesh, like geometrically, right? Okay, so to make the z projection, we can actually just use the let's see, the direction we have here, right? So the direction is going to be let's see, is this going to be correct? Yeah, the direction is going to be the coordinate we want for the outer one, I think. So if we go to, let's see, what order did we have? We have the outer one and then the inner one. The outer one is going to be the coordinate of the direction we have in the unit circle, right? Like this direction right here. But we need to remap that one. I think the this direction is between 0 to 1, but we want it to be between no, this direction is going to be between -1 and 1, but we want it to be between 0 and 1. So to do that, we need to offset this one, right? So we can do that by thank you for the follow. We can do that by multiplying this by 0.5 and then adding 0.5 to this one. Yeah. Because that takes the range from -1 to 1, scales it down so it's between -0.5 to positive 0.5, and then we add a half to both components, which makes it from 0 to 1, right? So that's the outer one. Then we need to figure out how, kind of the ratio between, let's see, so if we go back to Photoshop, this one needs to be whatever percentage we have of the inner radius of the outer radius, right? So we take the inner radius and divide it by the outer radius, and that gives us the length of this vector going to this one, right? So in that case, we can do the direction, and then we multiply that by the inner radius, radius inner, divide that by radius outer, and then we need to do the same remapping here, right? So we can just do that. Okay, is that good? I really want to make a local function now to do this thing, but anyway, not going to be needed, I suppose. I think that'll work. It might not. I might have missed something. All right, let's see. Let's switch to project Z. That seems to work. We don't really have a texture to test this with, but we can see the coordinates, right? Yeah. Okay. Actually, we could have a texture for this. So the texture will have a hole in the center. Kind of, yeah. It's just not gonna be, there's no geometry there, so it's not gonna show up there. Okay, so let's make a material that is simply like the thinking face, unlit textured. We can probably just use one of Unity's. Yeah, that one. There we go. Then we apply it to this one. So now we have the UV coordinates that are mapped with the top-down projection, just the same way we had in Maya, right? So that would be this one right here. And then the other case was the one that was like stretching it around. So we switch to angular radial, we get this stretchy one, right? It looks very sad, this thing. Yeah. That's better. All right. Did that make sense? Of all of that stuff? Let me know if it didn't. Always feel free to ask questions. There are no dumb questions. Well, there are dumb questions, but if you're like genuinely want to like learn stuff and are curious about how things works, none of those things are dumb questions. And the alpha, the shader doesn't use the alpha value of the texture right now, so there's no transparency in the shader, so it just doesn't happen. It was easier because it's the same principle that generates the points. Yeah. I guess the tricky part is, you know, knowing that you had to get the fraction of the inner radius based on the outer radius in order to get the inner UV coordinate, right? But yeah. All right. So I hope that makes sense. Is there anything else you want me to talk about? Unless I have different orientations. All right, I need some more water. Whew. Animations? I mean, the animations are probably better off being made in a shader rather than on the CPU side. I don't think I would do animations on the CPU side unless they're like very, very specific. Because that's much, much faster to do on a shader. Like in the vertex shader, you can move around the vertices there. But we could do that, but I just don't know if that would be... I don't think this tutorial would be about that, because this is not really about shader coding. So if you don't know shader coding, I would kind of like jump into the deep end of that, but I could do that if you want to. But why generate the mesh then? Because it needs some mesh data to animate, right? And then you need to pass data to the shader as well. Without data in the shader, you don't know how to like use it and animate it, right? So like you can generate a mesh once that has all the data you need to animate it, and then you do the actual animation in the shader, right? Which is a very common thing to do. Actually, why don't I just show that? Why not? It's not going to take that long. So let's just move this one to some appropriate location. There we go. All right, say we do want to animate this one. Let's just make a shader. All right, let's make a material out of that. Assign that one. Might want the thinking face again. It's important. There we go. Now we got a shader. So okay, so let's say we want to animate this one now. First off, it's probably useful to see, you know, what do we want to animate this one around? In this case, we got a very handy tool, which is the UV coordinates, right? So if we just do return UV coordinates, God damn it, Thor. The cat got stuck in objects. All right. So this is the X coordinate. That looks fine. Let's turn off the grid. Can you make a path on this object for deforming it? We could do that as well. I was considering talking about that after we're done with this circular segment thing. Okay, so let's say we want this to be, we want some waves to animate along this whole thing, right? So then let's just do the math for that. Let's see, we need tau in this one too. So let's add a constant for that here. So now we got tau, remove the F. There we go. All right, so let's generate some waves on this. So in this case, we can do the, if we take the sine of the x coordinate of the UVs multiplied by tau, that gives us the angle in radians, right? And then we can, this gives us a value between -1 and 1, right? So let's call that wave. And then say we want to remap that one to 0 to 1 again. So we can do the same thing as last time, although it's a bit more convenient in shader code, because we can simply do times 0.5 then plus 0.5. We don't need to like tell it that this should be cast to a vector 2 or whatever. Yeah. Okay, so this looks innocuous enough. So now it's doing a sine wave, but it's doing like a single wave across this whole thing. So we might want to multiply this by how many waves we want to have, right? So now we've done that. And then we want this to animate across this whole thing, right? So then we can add underscore time.y. So that adds a time value to this. So that adds an offset in sampling the sine wave, right? What if you want to do waves in the inner ring but not the outer? Shader does not have this information about what's in the mesh, right? So the shader does have the UV coordinates. And again, if we look at if we do return i.uv.y, this value is going to tell us if we're on the inner part or the outer part, right? Because these UV coordinates have a value of 0 here and a value of 1 here, and then they're interpolated across this whole surface, right? So if we go back to the waves over here, then you can see that we only use the x coordinate here, but if we want to modify this by the inner coordinate, we can just like multiply it in, and now we've like faded it near the center, right? Or if we want to, yeah, or whatever you would want to do. So you do have information about that. Okay, also thank you for the follow. All right. Okay, so let's say we want to use this as our offset. We might actually want the -1 value here, but let's just move this into the vertex shader because we want to modify the vertices with this, right? So we're just going to take this code, slap it into the vertex shader, and then we're going to do, then we're going to modify the vertex y position here. So we're going to do v.vertex.y plus equals wave, right? So now we're just modifying the y coordinate. Actually, we want z coordinate. There we go. And then let's see. We probably want to go back to having that one. We're in Maya. That's not. There we go. Undeclared identifier I, because I doesn't exist. So that would be v.uv. There we go. Okay, the amplitude of these waves is 1 in this case, which is probably a bit too much. So we might want to make a parameter for that. Wave amplitude, amplitude, and that's going to be float. Actually, let's do a range between 0 to 1, because I like sliders. Set that to some lower value because 1 was a bit too much. All right, and then we need to define that in here. There we go. Should probably have statics at the top. And then we want to multiply this here. There we go. That's much softer. I like this. So now we can set the wave amplitude here with the slider on the material itself. So the advantage of doing this is that doing this vertex animation that we're doing here is actually just done on the GPU. So when we render this mesh, like as the vertices are being rendered, or as the mesh is being rendered, the vertex shader is going to transform these vertices right before it's going to show up, right? So this is going to be much faster than having the CPU do that for every single vertex. Yeah. Also, I want this to have a curve. I don't like that this is linear. I want to have a slope there. Let's fix that. We can just raise this to the power of 2, and then we're good. I'm pretty sure. Wait, that didn't work. I thought that would work. Why did that not work? Oh, I didn't save it? Why is my recompile button not working then? I'm very confused. Huh. Oh, right, because I don't have any vertices in between, of course. There are no... It probably worked in terms of the values. I was trying to change the ramp of it, but we don't have any vertices in the inner segment, so it's not possible to do that without adding another adding another strip of vertices on the multiple rings on it, right? But yeah. So if I would want to do animations, I would just do that in the vertex shader, because that's like so much faster. Yeah. We can probably apply this to other objects as well. Like all of this is just using UV coordinates. So if I add like change this into a capsule, the capsule is also going to work, right? It's very wonky and this face is looking very silly. Or a sphere. Sphere works too. Yeah. Is it possible to do more complex animation with the shader? You can do a lot of complex stuff with the shader. As long as you have all the data you need, you can do a lot of stuff there. Yeah. You mentioned that you're using procedurally generated meshes in the games you make, right? Can you describe any example use cases? Yes, I can. I can just show you. When you want some other object interacting with a shader, you actually need a C# script to make the connection with CG code. Is that using CPU as well as the GPU? Does that slow down shader considerably? Passing data to shader like that doesn't slow it down a whole lot, I've noticed. It doesn't really matter. As long as it's just setting simple values or assigning stuff to it, it really doesn't matter. Yeah. Okay, so here's a use case for the, let's see, let's maximize. Is it going to switch to the game? No. Thank you for the follow, boy. Here we go. So this is a game that I'm working on called Flowstorm. And in this one, I do generate meshes and that are extruded along a Bezier curve. So I can enable the tangents for this curve and I can reshape this one however I want, right? So this one is procedurally generated. Yeah, so this game is using Bezier curves all over, and they're procedural meshes. So if you, for instance, if you go into the scene view, and then zoom in on these, you can see that these are, you know, actual geometry. It's a bit tricky to get to the renderer. Where did I put it? Probably this one. Anyway, I have a lot of shenanigans in this one, so the like you can't select them because they're positioned in a particular way. But yeah, so these are just procedurally generated. Oh, did I maybe not have selection wire on? Oh, that actually does work. Yeah, there we go. So you can see the vertices on this one now, right? Yeah. Thank you, Saki. How did you do the tool controls? It's just a bunch of inputs, right? Like you would detect if you click, and then if you click within the thing, you can move the thing, right? Yeah. But yeah, all of these are just procedurally generated meshes, and then they also generate a collider, so you can like fly around and you know, play on this track, right? So yeah, this game, by the way, is the game that I usually work on stream. I usually don't do tutorial streams. I usually like work on this game while I explain what I'm doing. So it's kind of, I still try to keep it educational, but generally this is a game that I'm working on. Yeah. Anyway, I swear there was a game exactly like the one you're showing now and had a level editor people used. It could be the old version of this game that was like 5 years old, maybe a little bit older. Yeah. What's it called? It's called Flowstorm, this game. Sorry, I'm just catching up with chat. Yeah, the old one is also called Flowstorm. I don't know if I have a video of the old one. I don't think I have the old build on Steam anymore. It messed up the... hold on, let me check. Yeah, I'm already running Flowstorm according to Steam, so... no, I don't think I have that one here. Anyway, but yeah, it's that's it might have been that game. I don't know if it is, but so basically, for better performance, every animation should be made using shader. When is it not recommended to use shader? So the basically use shaders when you can. And if you can't, then you have to use, C Sharp, right? To do that type of animation. But keep in mind that it's expensive to do that. So try to avoid it as much as possible. Yeah, that's the flowstormgame.com is the old website. But yeah, it's probably broken, like the build we had online and everything. Like that's probably not working anymore. But yeah. But anyway, so this is a rewrite of the old version of Flowstorm. So this one does have like online multiplayer in case you want to play with people. The old one didn't. The old one had shitty garbage code that just didn't work proper. But yeah, otherwise it's pretty much similar and the same thing as last time. It's it's a 2D racing game, same way as usual, race to the end and whatnot, right? This can't be too old. It says it was greenlit and it used the old Unity web player. I mean, I worked on that game back then. This is a remake of that game because that game never released. We only had it on the website. Yeah, we only had it on the website for quite some time. It did grow in popularity, but then we kind of just didn't have the time to work on the game anymore. So we kind of just faded out of existence slowly. And then I've tried to remake this game twice since then. And this is the most recent iteration, which has gone much, much, much further than than the second iteration of this game. I was on that team. It was a pretty small team. I did everything except like 2D art for that game. Although I'm doing this one solo now. Thank you for the follow, Lifegood. Anyway, yeah, so back on topic. So this one is using procedural geometry, and in its level editor, right, for the Bezier curves. There are a bunch of edge cases that make this like very tricky when it comes to like these linear curves and having curves like this, where you have these like sharp intersections, or even worse, if you have two Bezier curves like this. Let's see, if you have two Bezier curves and then you break the tangent like this, you get some really hacking, like weird edge cases. So if you go to the scene view now, you can see that like I need to be able to cut the meshes, right? Hold on. There we go. So these meshes need to be able to clip, because otherwise if I naively generate geometry here, that geometry is going to go outside of that mesh, right? And we don't want this one to go here. We need this one to be clipped. Solving that was a nightmare. It was such a mess, but I ended up getting it to work. It involves a lot of line intersection math and a lot of like shaders and whatnot, and yeah, it was a mess. But anyway, here we are. It is working now. So yeah. Really good looking tools. Oh, I need to remind you though that this is the level editor for this game is not a Unity tool. This level editor is in-game. So, this game is going to be released with the level editor, so people can make their own levels, because I think that's a really fun and enjoyable thing to do. So I think players would enjoy that, right? When will this get released? It will get released whenever it's done, pretty much. I'm not going to do a WebGL version. I'm just going to release this probably on Steam, I'm guessing, or the Epic Game Store or whatever. It's going to be on desktop for the most part. Yeah, I don't think I'm going to target any other platforms. I did consider targeting the Nintendo Switch for a while, but I'm not sure. We'll see. Yeah, anyway. Yeah, so this is what I usually stream. This is what I generally work on. And if you're interested in this game, it's actually sort of semi-available on Steam already. It's currently under a like closed alpha, so it is on Steam, but it's not public yet. But if you do want to play it, I actually do have keys that I can give you. So if you want to play this, if you donate $10, I can send you a Steam key of this game. There's no guarantee that I'll release this game though, because I'm not working on this full time and I'm not sure, even when it's going to be released. But I have been working on this live on stream for the past year now, I think. Not entirely sure about the time frame, but yeah. So this is what I'm working on for the most part on stream. So yeah, if you do want that, feel free to back me on Patreon, or send a one-time donation. That's totally fine too, and you'll get a Steam key. Anyway. Yeah, so that's it. So that's a use case for procedural geometry. I hope that made sense. All right, where were we? So thank you. I do appreciate my avatar. What do we do next? We could start doing the Bezier curves if we want to like extrude stuff along curves. Can you deform that along a path? Yeah, we could start doing path stuff. Okay. Do you want to do that? Would you be interested in doing like how to extrude something along a path? I actually did a talk about this at Unite. I mentioned it earlier. So if you do want like a more condensed talk on exactly that, it's available on, who is it? It's Unity's YouTube channel. They have I think it's called Procedural Mesh Generation for a Coder. No, a coder's guide to procedural geometry, I think, is the name of the whole talk. Keep forgetting that, but how do you have 2.5 dimensions? 2.5D is generally a term you use for games that have 2D gameplay but 3D graphics. Right. Was this your cousin's talk? Yeah, it's that talk. Yeah, there was someone who asked me if it was my cousin or something who did that talk. That was very cute. I was like, oh, no, it was me. What happened to the old team of Flowstorm? Why didn't the game launch? We got a VR dev kit from Valve, and then we started working on budget cuts instead. And then after a while, I just kind of started working on Flowstorm on my own, so it's no longer part of Neat Corporation, which is the studio that I work at generally on my day job. So there we released Budget Cuts recently, which is this like stealthy VR game. But yeah. Anyway, that's why Flowstorm was like kind of halted. Actually, that's why it was halted the second time. The first time it was halted was because we just needed money. There was no way to do it. Yeah. All right. Do I want to do Bezier curves? That's going to be a deep dive, probably. Because then we need to go through Bezier curves first before we go into anything else. But that's pretty straightforward. And I love explaining Bezier curves because Bezier curves are awesome. Okay, in that case, I'm going to need to get more water and I need to go to the bathroom. And yeah, also, heck, thank you all so much for joining. This is fun. All right, I'll be right back. Right. 69 viewers. Nice. Wait, was Thor walking into the picture? Are you gonna play World of Warcraft Classic? No, I never played the original, so I have zero, like, nostalgia. I did play World of Warcraft a while back, though. As in 1 year ago or something. But I wouldn't want an old version. That's just like a shitty version, probably. Like, the only value in like rolling back all your changes to an old version is just because of nostalgia. It's probably, the new one is probably way better in terms of like, probably so many convenient new features that are just good. That people just don't like because it's not the original, right? Whew, okay. are you all, do you all want to do Bezier curves and stuff? Like, is that okay? Or do you want me to like focus more on just procedural geometry? I think that might be the thing that I should do next, because I'm not entirely sure what I would do otherwise, actually. I feel like I've kind of gone through the fundamentals of procedural generation for meshes. Yeah, let's do Bezier stuff. It's fun. You're gonna get lynched with that one? Nah, probably not. It's fine. All right. Should probably. Actually, I might as well keep this one open. But yeah, that was my World of Warcraft hot take. Feel free to clip that one and post it on live stream fails of like, wow, oh no, the streamer destroys her career because of opinions about the video game. Yeah, I mean, if you did play the old version and you have a lot of nostalgia and that's valuable to you and you would relive that nostalgia playing the, playing the World of Warcraft Classic, then, I mean, sure, go for it. If you enjoy it, then why not? It's probably just a good thing for you. But for me, I have zero nostalgia, so like, what's the value for me? It's just gonna be the old version with a lot of the super convenient patches just gone. Anyway. All right, let's do Bezier curves. This is gonna be neat. All right, how do we start? Do we make a separate Bezier class, or no? We should probably do a let's see. Yeah, we should probably start with an object that we can use as a base where we're going to generate all the meshes, right? All right, so let's call this, what do we make like a road segment as usual? I feel like that's a good test case. Let's call it road segment. All right. So what do we need in this one? We need a mesh filter, and I need to stop hitting the wrong keys on the keyboard. So we should probably require the mesh filter component. Type of mesh filter. Okay. So now we got the script. We should be able to make an empty object now, and we're gonna have the road object on this one, and road segment. Can remove this component. Let's move this up there. All right, unlit UVs. Sure, why not use that as a shader? Whew. Okay. First off, we need to be able to have a spline where we can define the shape of this object, right? So that's the first part of this. So to do that, we need to have a function where we can get a point along a curve, specifically along a Bezier curve, right? And then the cubic Bezier curve has 2 control points and 1 start and 1 end point, right? So we need those points somehow. If we want to easily have points that we can manipulate and move around, it's probably easiest to just use transforms for that. So let's make an array of points. So that's going to be our control points. There we go. And then we can probably do something like get position, like a function for that. There's just like vector3 get position of an index of a point, and then we'll return control points I dot position. There we go. So now we have a bit of a shortcut, so we can like easily access a specific position based on these transforms. All right, so now we need to assign to this array. We kind of like presume that this one is going to have 4 objects. I think, can you initialize arrays in Unity to a specific count? Probably not, but let's try. Also, this one needs to be serialized because we want these as inspector fields. There we go. recompile. Control points. It actually did initialize with 4 slots. That's neat. Alright, so let's make a bunch of empty game objects. So these are going to be our control points. Let's see. So this is the segment, and then this is going to be 0.0, and then we have 0.1, 0.2, 0.3. There we go. Hacking boilerplate. There we go. All right. First off, we need to be able to draw these things, right? So, actually, this is specifically the world position, which we probably don't want later, but let's use that for now. All right, so we need to use the onDrawGizmos function, and we're probably going to want to draw these always, not only when selected, because we need to be able to select the control points, because they are separate transforms, right? So, all right, so we have the gizmos functions, and then we want to draw each of these points, so we can use gizmos.draw sphere, and the center point is going to be get position, so we're going to want to iterate through all of these 4 points. There we go. And then we want to draw the sphere from the position of get position I, and the radius is going to be, I don't know, small enough, I guess. Something like that. All right. So now if we go back to not the wrong Unity editor, let's go to the correct Unity editor, recompile,